put your hands together for Emily J. Ryan.
Hello, developers. So, welcome everybody to Innovators Hive here at Google Cloud Next. So my name is Emily Ryan, and I'm leading our technical customer engineering cloud native team for startups and scale-ups across Europe North. And we have the opportunity to work with developers like you every day, and this is really what we love most about working at Google Cloud. I'm so excited to be here in Munich today, and thanks to all of you who have joined us here in person, and a big warm welcome to all you folks joining across Europe, Middle East, and Africa online. Hello, Internet. So, today's event is about sharing the best technical content across our very broad platform in a special hybrid setting so we can really reach all of you where you are. And in this full day of content, you'll get to hear from our Google Cloud experts, from your local community members, and from our champion innovators. Plus, you'll have a chance to interact with some cool demos. You can ask our Google Cloud architects about your individual questions, and you can ramp up on skills in our arcade. And what would be a developer day without swag? So we already handed out a little bit at the beginning, but we have even better stuff as a reward for you folks attending all of the sessions. So you should have a stamp card, and if you go for the first 10 minutes of a session at least, you'll get a stamp, and then you can collect those for swag at the end of the day. So if you enter the session after 10 minutes, your card won't be stamped, so German punctuality is a plus today. So the more sessions you attend, the more swag you'll earn. And if you stay for our 2 hands-on workshops at the end of the day, and you'll get even more stamps. So it's worth it, plus we have a party afterwards, so definitely don't go anywhere. So here in the venue, we have 2 technical tracks that you can follow. So one in the room here, and one is upstairs on the first floor. You can look at the back of your agenda, name tags. The agenda is on the back. So join the sessions from the beginning to get your stamps. Each session is only about 20 minutes long, so we're really packing the content in. And then you'll have a 10-minute transition and break in between. I'm also super excited to announce that all of you as attendees of Innovators Hive can register to get access to the Drone Racing Challenge. So we created this in partnership with the Drone Racing League, the DRL, to usher in a new era of tech-driven sports. So you use race data and Google Cloud Analytics tools, and developers of any skill level, really, from around the world can predict race outcomes and even give tips to the drivers and pilots to enhance their season performance. You will compete for a chance to win an all-expenses-paid trip to the season finale of the DRL World Championship and be crowned on stage as champions. So outside, there's more info for this, and register, and super excited to see who ends up on stage, hopefully somebody from Europe. So we have talks, we have games, we have swag, we have hands-on demos, we have food and drink. You will be well taken care of on the ground floor and the first floor. So really take advantage. Don't forget to explore and exchange with our Google Cloud experts and talk amongst yourselves, and really get inspired to become innovators on Google Cloud. So let's get this started. For our first keynote, we have all the way from San Francisco, Matt Thompson, who's our Director for Developer Adoption. And Matt's going to share the latest on what we're doing in Google Cloud to continue to grow the impact of developers in EMEA and around the world. We want to make Google Cloud the most intuitive and easy-to-use platform, and we're going to share our continued investments in critical areas that you care about most, like developer security, data and AI, and just how to get your apps up and running quickly and safely. So without further ado, welcome to the stage, Matt.
Good morning. Good morning. There we go. So I wanted to thank you all for being here. Actually, I think this is a very civilized time to start an event, so I appreciate you all being here. When I first heard about the event, I was thinking, please don't let us start at like 8 a.m. We had people in New York. I was just in New York earlier this week, and we started the event at 8:30, and I was like, wow, that was early. And New York's very crowded, hard to get around, et cetera. The other thing I wanted to mention, and this is a personal thing for me, is I wanted to thank all of you for being here in person, and I know we have a huge audience online as well, and I want to welcome all of them. And actually, I have a small story to tell. My daughter, who is studying computer science at the university, is actually awake right now on the East Coast of the United States watching this. So if I screw up, she's going to tell me. I know she will. But I wanted to say, this is the first time I've been back in person at an event other than the event earlier this week. And so thank you for joining. It's a huge thing for us to get back and see and engage in the community firsthand. And I hope you enjoy this. There are a number of things that we're going to talk about today, including new features for our cloud, some of the thinking that went behind it. But I want to start with something that I'm going to finish with as well. We build our cloud for developers. Google exists as an engineering company for developers. It's why I joined the company. It's why all the other speakers that you'll hear from today are part of the company. And when I was just in New York for the kickoff of this event globally, one of the things that was really interesting is I wasn't meeting with developers. I was meeting with CEOs and CTOs and CXOs from a number of our top customers. And it was a great conversation, and I'll share a little bit of that a little bit later in the talk. But what was interesting to me was that I wasn't talking to people who write code. And that was missing. So I hope today we get to explore some thoughts on the type of code you're writing, the types of applications you deploy, and even if you don't write code all the time anymore, if it's in your background, we still want to hear about that. And we'll talk a little bit about in this keynote why that's really important going forward as well. So the other thing I want to mention is, why are we here? So Munich, beautiful city. I'll share actually that in the middle of the pandemic, I did take my family on vacation, and we were, I'm a scuba diver. I usually have a slide up of me scuba diving somewhere. But one of the things that we did is we actually finished in this city. Our vacation finished in the city, and we spent 3 days here. It is an absolutely beautiful city, especially in the middle of summer. It was absolutely gorgeous. And so why are we here? Because this is a center of innovation. EMEA also is a center of innovation, and I want to talk a little bit about that. There's a long history of innovation within the region. Some of that goes all the way back to CERN, where the World Wide Web was developed. But we see innovation coming from the region and across sub-Saharan Africa and the Middle East as well. And so we're here because we think this is an important place to invest our time and our effort to see what you're developing and to hear from you what's next. So the other thing is, it's a very large region, and most people don't necessarily think about this. There are actually more cloud developers in the larger EMEA region, including Middle East and Africa, than there are anywhere else on the planet today. Well more, several million more than we see in North America. And that's meaningful. It means that there's a community of like-minded individuals here innovating, developing, bringing new workloads to bear. This is a really important thing for us and why we're here. So there's also one more thing I want to talk about from the perspective of how we engage with our community. So how many of you are familiar? You might have heard from Emily, our Innovators program. How many of you have heard of our Cloud Innovators? So it's our developer program. It's free. You're going to hear me talk about it a couple times today. We would like all of you to go sign up for our Innovators program by the end of today, or when you get home. But inside our Innovators program, we actually have a tier of what we call champions. These are community leaders and technology leaders that have kind of stepped up and said, we want to help build cloud and have cloud engage around cloud technologies in all the various communities in which developers engage. And that could be user groups, that could be meetups, it could be our own cloud GDGs. Interestingly, we have more champions in EMEA than anywhere else in the world, by actually quite a bit. And that says two things to me. It says that there's a large, robust community of technical leaders in the region, and also that you're very community focused and oriented. And those things make a huge difference when we talk about the proliferation of innovation in regions. And I can tell you lots of stories. I've had the opportunity to travel all over the world to talk to developers. Interestingly, part of it is cultural. In some places, sharing just isn't something that you do. Here, sharing is part of what you do. Getting together, talking to people, sharing ideas is a key component of this. We all want to learn from each other. It is a human trait. My team is like this, I am like this. Today, I'm hoping to get a chance to meet with a number of you and just hear the ideas that you have and what you're building. So for us, this is a key measure for us. And I expect EMEA to continue to lead in this measure going forward. So great job. If there are people in this ecosystem today, in the audience today, that are interested, please join our Innovators Program. And if you're leading communities, if you're influential in your company, come talk to us. There are opportunities to do more. So it's not just about communities, though. Where do we see actual innovation happening? One of the places we look often for signals for this, startups. So startups are interesting because they tend to consume faster, they tend to adopt faster, they also tend to pivot faster. If a technology's not working, what do? They go try a different technology. If it's not working on one cloud, they may go work on another cloud. And interestingly, for us, startups are a key focus. We can actually see what's working, what's not, at a much faster pace in the startup ecosystem. And when we talk about the startup ecosystem for EMEA, it's not just one location. It's not just London, it's not just Paris, it's not just Berlin, it's not just Barcelona, it's not just Tallinn, it's not just Copenhagen. It's across the entire region. And we're seeing it emerging in other places in EMEA, places like Cape Town, Lagos, Casablanca, Nairobi. And these startup ecosystems are also places where we see the great sharing of ideas as well. So we use this as a measure for us to see how fast technology gets adopted, what's working, what's not working. So I just want to see a show of hands. How many of you would say that you either work in a startup or have worked in a startup within the last 10 years? It's a significant population. That's great. We love that. That's a hunger for innovation, a hunger for learning. But we'll go farther. It's not just startups. Our largest customers also are using cloud technology to learn and drive. And so an interesting example here is Lufthansa. Lufthansa used our Vertex AI engine and our ML tools to figure out how to create flight schedules that were more accurate. So flights on time. How did they do this? They analyzed wind patterns in their airports. And what this allowed them to do is forecast with our tools to be much more accurate. And actually, they have one of the highest on-time arrival ratings for the entire world because of this. So that's an example of an enterprise using our technology, our cloud technologies, and specifically intelligent data to build their business model and make it more effective. So the other thing I want to talk about is, so we've talked a little bit. So we've got community. We've got startups adopting technology quickly. We've got enterprises adopting technology to add value propositions to their business. What about security? What about privacy? These are huge, important things in EMEA and now worldwide. So interestingly, within Google Cloud, we've implemented a number of systems that allowed you to protect data, enable privacy, and so things like the cloud data loss prevention. And if we go a step farther into healthcare DID, the notion of being able to have private data stay private when you're working with things like medical imaging. Really important. How do you both for personally identified information, being able to store that away and keep it private, as well as private health information? Super important. And so we use these things, these kind of scenarios, to make sure that we are building what we hope will turn out to be the most secure, the most private, the most extensible, and the most powerful cloud that exists on the planet. And we know that's very, very important for the region. And by the way, EMEA is leading in this area. We're now seeing it emerge in places like Brazil and Singapore and Indonesia and Japan. We know that this is an important thing, and we expect to deliver on this. And what we say is that these are kind of cloud building a cloud on Europe's terms. And so we're kind of collapsing it down from EMEA for a moment to Europe because there are very specific needs inside the EU, things like GDRP and a number of other things. We expect to build the most robust, most private, most extensible, and most powerful cloud on the planet. And we don't just say that, we're actually implementing that. So before we go and talk about our trusted cloud for a bit, I want to talk about the other part of this, which is great. Building one example of a cloud, bringing one region, isn't going to help the people around the world. It's not going to help developers deliver their innovation to all the customers that they may have, in region, out of region, worldwide. So what we recently announced is we have a new cloud region in Milan. It's now open. An additional one in Paris. And an additional one in Madrid. But that's not enough. This week, we announced we'll be bringing new cloud regions to Norway, Sweden, Austria, Greece, and South Africa. And for those out there on the internet listening to this that might be in sub-Saharan Africa, this is part of the billion-dollar investment that Google announced in spurring innovation in the region. Because not only do we want to enable reaching customers across Europe and the Middle East, but also Africa. And so we expect to see the huge amount of startup activity that we see in places like Cape Town, Lagos, Nairobi, and Casablanca, to start delivering innovation to customers in those areas as well. In addition to that, we've announced that we're expanding with Doha, Turin, Berlin, Dammam, and Tel Aviv. These are all cloud regions that we're bringing to market over the next months. And what does this allow you to do? It allows you to build locally, but deploy globally. And deploy your services as close to your customers as you need them to be. This is the largest single investment that Google has ever made in anything, is these new data centers. And we will continue to grow out. We expect this to be a global footprint for local development. So to talk a little bit about our trusted partner cloud and how we're approaching this, I'd like to ask Julian to come up on stage and kind of dive into the details of some of this. Julian?
Thank you. Thank you, Matt. My name is Julien. I'm a Googler based in Brussels. I've been working many years advising organizations around the world and in Europe to handle sensitive data sets and workloads on Google Cloud. To connect to what Matt just announced, to be truly global, we must be local. And indeed, for anything relating to sovereignty, residency is a necessary condition. However, there is much more to residency to achieve sovereignty. And these additional abilities are what makes Google quite unique in how we respond to the sovereignty expectations growing everywhere in the world. Sovereignty is not about more security. You already benefit from a level of security very few can match when you deploy your or your customer services on these world-scale, frankly, world-class infrastructure. Sovereignty is about trust. Every day, we meet organizations around the world that frankly make suboptimal decisions when it comes to innovation ability, scalability, resiliency, even security, and sadly, sustainability, because they lack the trust to engage on cloud. Unless we fix that trust issue, also a cloud issue, we will not be delivering on our mission. So what is it exactly that we are solving for? In countries where we operate, we engage closely with customers, but also regulators, and we listen to lawmakers. And we hear three distinct narratives unfolding. The first is very familiar, is all revolving around data protection, security, and privacy. Since the arrival of the GDPR, Like many others, we've been on top of this. And it's not to say that things are solved, far from there, but honestly, we are seeing good development, good tractions, and good progress in that direction, both from the technical side, also from the legal side, and even from the political side, as we might have read, you might have read last week. There is a second discussion, which is gaining traction these days, is related to the economic imbalances created by the uneven distribution of technology in different regions of the world. To paraphrase a French minister on this topic, we as Europeans have been there before. We will remember the discussions around nuclear energy knowledge or commercial airliners in the 70s. And we have fixed this, and we will probably collaborate our way through this game again to be back into this game too. The third element is the reality that any responsible technology decision makers today cannot abstract the risk of having certain services not available in a certain region. This might unfold in an unexpected way, by the way. We have seen some countries having to pass laws or make decisions to get their data outside of their boundaries recently to keep the data more protected. So residency is very important, but access control is paramount. For some of these services, you or your customers will want control over these cryptographic keys. In September 2020, we published a vision outlining our working direction, and we stated that sovereignty, while strongly anchored into data protection, really goes beyond that. And what we are seeing is a deeper need for operational sovereignty, really the capability for local partners to have more, if not full, oversight over the cloud that their customers are using locally. Finally, we embedded into the vision the need for our customers to continue operate in situations where connectivity cannot be guaranteed anymore, either for technical, legal, or political reasons, delivering on a software sovereignty vision. A year later, in September 2021, we announced our first partnerships with T-Systems in Germany, Thales in France, Minsa IT in Spain, and TIM in Italy, to collaborate and develop together a portfolio of trusted cloud offerings for Europe. A year later, September-October 2022, we are announcing the first products coming out of these relationships. Google Sovereign Controls offer the ability to define the location of your customer data, control who has access to the customer data, and keep control over the cryptographic keys, including outside of Google's infrastructure. If you do not have these three technical controls, you do not have data sovereignty. You might want to use additional GCP core services or controls, like DLP was just mentioned, to de-identify the data, or confidential compute to keep data encrypted while in use. Our partner-managed services, or partner-managed sovereign controls, add an extra layer of control, an ability for local partners to control, monitor and control Google's access to the customer data, and add a layer of visibility and full control over operational elements. The supervised cloud offering, when ready, from France and Germany, will be operated by local partners in country, allowing to serve specific data sets or specific requirements, meeting specific regulatory demands, like, for example, the Secnum Cloud in France. Finally, there are scenarios where less reliance on the cloud provider is necessary, and our hosted cloud solutions are working towards being able to operate in disconnected, fully air-gapped environments, meeting these software sovereignty ambitions. Delivering sovereignty is not a trivial task, not for us, also not for you, or anybody having to set these things up. However, we understand its importance, and we're engaging on this journey to deliver cloud on Europe's terms, a set of carefully crafted solutions put together with the local partners, but really aiming to deliver the true value of the cloud in a way that is acceptable by your global customers, starting in Europe. I want to end with a small reflection. We, as technologists, are basically laying down infrastructure, and infrastructure can last a very long time. It is not the first time that infrastructure is laid in times of high mistrust. The railways in the 1870s, electricity after the Second World War, and still today, when you travel through Europe and you take the train and you want to cross from France to Spain, you have to change trains because the rails have been laid in different width. Our task is to meet our customers' expectations today while not contributing to a long-term fragmentation for tomorrow. Having said that, Matt, you're welcome back on stage. Yeah.
Thank you, Julian. Okay. So I want to talk a little bit about developers, you. I've been doing this for a long time. I'm not going to tell you how long because it makes me feel bad. But I will tell you that the first project I work on was actually writing a C++ compiler for a company that doesn't exist anymore. I was actually very proud of doing that. We actually were taking C-front technology, throwing it out, and writing a native C++ compiler. And at the time, I remember thinking, nobody cares. Because the company I worked for didn't care about the C++ compiler. The people who were going to use the compiler did care, but they were using it because they were trying to create an interesting application or something like that. The fact that it was C++ would just happen to be the language they were using. Today, I'm going to tell you, and I think many of you feel this way, developers have never been more important. And I want to share a very quick story about my time in New York just a few days ago. I was sitting at a table with 7 or 8 CTOs, CXOs from some of the largest customers that Google has. One of them happened to be a CTO for a large bank. And he decided to share. I asked the question, so how important are your developers? How do you treat them? How do you recruit them? How do you pay them? How do you reward them? What role do they play in your organization? And he said something very interesting. He said, we're a large bank. We have a regulatory piece of the business that we have to account for. And then we have customers, both commercial customers and consumer customers, that we want to provide the best service to. So we set out what we're trying to do from a business perspective, and that's all done by executives and people like that. But the choice for tooling, application frameworks, cloud, all of that decided by the developers. And he said, after fighting for 10 years with developers on trying to tell them what they need to use, he just gave up. And he said, it's much more efficient to let them choose. Now, he said, the thing we always have to be careful about is the proliferation of tool chains and everything else. So he actually makes the developers get together and say, we are going, for this project, going to standardize this language, this framework, this tool set, this deployment environment. But he says it's much better than anything he's done in the past. And I'm here to tell you, that's the world we're moving to. If you don't feel it today, you will feel it in the future. Everywhere we go, all the developers we talk to, there are examples where developers are the leading innovators inside companies, and they have outsized impact on the decisions being made. That's important. That's why we're here. That's why we're talking to you. We believe you hold the keys to the adoption patterns for the next 10 years. We'd like you to choose Google Cloud, obviously, but you hold that ability in your hands. And so interestingly, one of the important aspects of that is that we all have to keep learning. I call myself a lifelong learner. I believe in that. I am constantly trying to learn about new technologies that come into the market. And so what we've done is we've built a program to help you do that as well. We want to increase your commitment to learning new skills. So a year ago, we launched a program and we made a commitment that we wanted to reach 40 million people to increase their cloud skills over the next 5 years worldwide. And we have our Cloud Skills Boost program as part of that. But this week, we added to that. And now what this includes is something that we're calling Innovators Plus, similar part of the program, where we're providing cloud credits, certification vouchers, and opportunities to engage in live events like this as part of the subscription. So everybody learns a little bit differently, but if you're interested in learning through formal programs, sign up today. This is the URL. This is a great way for you to get up to speed and stay engaged with what we think are going to be the most important skills in the cloud environment going forward. So, what we're also trying to do with our platform is make it easier for developers everywhere. We've talked about all the data centers we're opening up. We're talking about the regions. We want to make it easier for you to do what you love. And having spent time as a developer, I know people don't like running down bugs, working out deployment issues, trying to figure out why services are not as performant in one region versus another. Those are the things that we're trying to automate for you. And along those lines, I want to talk a little bit about some of the things that we've done. So, for example, for containerized applications, Gke Autopilot now will allow you to deploy and run faster, 2.6 times faster on Google Cloud than any other cloud platform. Using Cloud Deploy for continuous delivery, 2.4 times faster than any other cloud platform. For Cloudrun, for serverless, for DevOps type things, 50% faster on our platform than others. Now, those are all nice, and that's all the innovation that we intend to keep on bringing. But there was something we announced this week that's really important. I just want to stop for a second, because it's not all about trying to get your code, get you to deploy, to develop, deploy, and operate your code in an easier environment. We also want you to be able to do it more securely. So I'm going to take a risk here. I just want to see, from a show of hands, how many of you write code today as part of your job? Excellent. Keep your hands up. Keep your hands up. How many of you really deeply inside care about security? Keep your hands up if you do. Interesting. Let me tell you how that usually goes. All the hands go down with maybe 2 for that last one. This is something that I've been involved in from the very beginning. It's something I think is very important. So we announced a new product today, or this week, called the Software Delivery Shield. It has a number of components in it that I'm going to talk about. But I'm going to tell you that the goal of this, for the first time, is going to be able to get developers to care about building secure software without having to do extra work. So this is not getting you to care and having you to do more work. This is getting you to care doing what you're already doing. So we're going to talk a little bit about this, and then we're going to actually show a little bit of it. So the first thing is we've got Cloud Workstations. So some of you may have heard we announced Cloud Workstations this week. Cloud Workstations is not just another IDE in the cloud. It is actually an environment, a secure environment that allows remote workers and contractors and vendors, as well as other developers, to build securely. And within Cloud Workstations, we have what's called assured open source software. How many of you today consume open source software as part of your environment? Yeah. Here's a question. How many of your managers are worried, like on a weekly or monthly basis, that they don't know what's in that open source software? Yeah, it's actually a very big issue. So through assured open source software, what we've done is we've gone through and started with 250 of the most important Java and Python libraries and provided our level of assurance by doing the testing, the analytics, and the fuzz testing against these so that you can use them, consume them within our environment completely securely. There are other companies that have tried this in the past, but nobody's done it at Google scale. And we're not stopping at 250, and we're not stopping with Java and Python. For the first time, because we do this for you to consume open source projects, libraries, artifacts, et cetera. We want to make sure that you feel that it's a completely trusted piece of software that you're bringing into your environment. And that's what assured open source software is all about. In addition, we're adding security into the build environment. So within Cloud Build, we now have SLSA Level 3 support, threat prevention, which allows you to trace back all the software components that you bring into your environment. Allows you to build in an assured fashion. And then last, within GKE and serverless, we now have opinionated deployment options for you. So rather than handing you, and I won't quote the number of docs pages you'd have to read to actually use GKE effectively and figure out all the different options, we're now providing opinionated views of that, so you can choose one of those configurations in a completely secure way. And so what I want to do now is bring somebody up on stage, I call him the mad scientist, Abdul, to kind of, rather than just talk about this, show this to you. Please welcome Abdul to the stage.
Thank you, Matt. I've been given the awesome task of doing a demo, so let's see what can go wrong, right? So I'm very excited to be here. I'm going to do a demo, and we're going to talk about this fictional company called Symbol. It's an e-commerce company. They sell things online. They are based out of the US, and they run on Google Cloud. They have adopted Google Cloud both in terms of technology, managed services, but also in terms of best practices. And the whole goal of this business, or really any business, is to run in a secure manner, but also remove innovative. E-commerce is a very competitive domain. So this is how their microservices looks like. It's just a microservices-based environment running on GKE, protected by our overall solution called the Software Delivery Shield. If I get back the demo laptop, please. So these are the services in GKE. As you can see, just pods, for those of you who are familiar with GKE, running containers. And one of the softwares, or one of the solutions that Matt talked about as part of the Software Delivery Shield is this new thing called the Gke Security Posture. So what it is essentially a dashboard that gives you an overview of all your clusters in the project and tells you both vulnerabilities, but also misconfiguration. So let's see an example. I can go to the Concerns tab, and I can filter on configuration, and I want to also only look at the high ones. So here I have, for example, one of them, which is a pod with privileged containers, essentially a pod that runs containers as root. This is against GKE or Kubernetes pod security spec. So here I can see which workloads are affected by this concern. It's not really vulnerability, it's more misconfiguration. And if I go back to the details, I have some recommended actions. So basically, I have to go and edit a YAML file and then set the security context privilege to false. I can also filter on vulnerabilities. And let's just look at the critical ones. So those are vulnerabilities in the current running workloads, right? So essentially what we're doing is we take every image and we scan it. So we just decompose the Docker file, look at each layer, and compare it against a CVE database. So here I have a list of all the potential CVEs that exist in those workloads. Again, I can look at the workloads. And from here, I can take this and make it an issue or a bug and make sure that the team can fix it. If you go back to the slides, please. Now, Symbol runs in US as well, but they want to expand to Europe. Let's say they are planning to just offer their services in Germany. They want to use Google Cloud to expand their presence in local markets, but they want to customize the front end. They want to make the front end more local, both in terms of the look and feel and maybe even the language. But what they're doing also is they're actually expanding their teams to Europe. So they have a new front-end engineering team that is going to be working on the local version or whatever of the front end of the app, right? They can do that in so many ways. One potential way is essentially keep all the backends running in the US on top of GKE and just use Cloudrun to deploy the front ends to the region where they are expanding. In our case, they will just have a front end per country maybe, or a front end for the entire EMEA. And we're going to see how they're going to do this end-to-end, starting with new developers who are not necessarily familiar with Kubernetes. They don't know it. They don't have to know it. You don't have to use Kubernetes for everything. They will be using Cloud Workstation, which is our fully managed development environment in the cloud, to write code test it locally, and then use Cloud Build and Cloud Deploy to deploy these workloads while ensuring the end-to-end security we talked about. So briefly about Cloud Workstations, Matt talked about it, is a fully managed development environment in the cloud, which allows you to write code in an editor that you are familiar with as a developer, but also to run your code locally, and by locally I mean in the cloud, it's not in your laptop, but you still run on an emulator, like Cloudrun emulator, you have PubSub emulators, you have a bunch of emulators. Everything is already integrated into the environment. And let me show you how that looks like. If I can get back, yeah. So this is how the app looks like. Just very simple online boutique app. I have products and prices and so on. This is my workstation. It's already up and running, hopefully. Finger crossed. Yes, it is. So it's just a workstation. Cloud workstations are actually private instances. They are part of the VPC, which means if you're using VPC service controls or if you're using ingress and egress policies, those policies will apply to the workstation. One of the advantages of using a cloud workstation in the cloud is that you can actually ensure that people cannot exfiltrate code. They cannot just dump code outside of the workstation. Or that if somebody gets their laptop stolen, people cannot just take code from the laptop because it's cloned on it. This is how the UI looks like. For those of you who are familiar, it just looks like visual code, right? But it comes preloaded with everything you need to be able to run code on Google Cloud. So let's just take an example. As I said earlier here, the example I'm talking about here is we're going to be able to write a new front end, but make that front end talk to backends. But because the front end and the workstation, in this case, and also my backends are all part of the VPC, I'm just configuring my environment such a way I talk to private IPs. So I don't actually have to expose my backends to the internet. Then if I go back to my homepage here, I can change this. I'm just going to do a very simple HTML change. Save it, and then I can simply do bring up the command palette and run on the Google Cloudrun emulator. So the Google Cloudrun emulator is just Cloudrun inside the workstation. And that, once I do that, it will give me a port forwarding page, and I can see that my changes have been through, right? So this is my developer cycle from code to testing locally. But everything is done in the cloud. Now, if I'm happy with this, I can actually go ahead and push code to my Git repo. I can do it from the terminal, but I'm feeling lazy today because it's still too early for me. So I'm just going to go ahead and do it from the GUI, right? I think some of you are familiar with this environment. So I'm just going to type a commit message and then just commit my code, right? And basically, if I go back to my code source, I have my commit coming through. I can look at it. I have to admit, I have done this yesterday because, demos. I don't want to risk it. So I have my code change. And the other thing I have in my code repository, which I haven't showed you, is I have a cloud build pipeline definition. For those of you who are familiar with Cloud Build, is our CI pipeline, continuous delivery. It basically takes a bunch of instructions and execute them in order. Here what I'm doing is I am running a Docker build, which will build the image and push it to artifact registry, which is where the image will be stored. And the second step is going to start a cloud deploy pipeline. I'm going to show you that in a bit. Let's start by looking at our cloud build. So this is the build that got executed yesterday at 11 p.m., and it worked. So I have two steps. I have build the image, and then I have executed a build pipeline. So one of the new additions to Cloud Build, which you might have not seen before, is this new tab called Build Artifacts. In it, I can see that I have a text file. So the text file actually is the logs, so the results of the build. And then I have the image here. And I can directly, from Cloud Build, look at the security exposure or the security insights for this specific image. So every single image that we push to artifact registry is scanned and is tested against the Salsa level 3 framework. So I can look at the provenance. So the provenance is, you can think about it as the recipe, how this image have been built. So I have a bunch of metadata like when was it built, who built it, how was it executed, what's the command that ran this, that built this image, when was it built, etc., etc. So this is just metadata that is added on top of the image, and that can allow me to do further analysis. So this metadata is used actually as an input to the Salsa Level 3 compliance. Salsa Level 3 is a build compliance framework, which was created by Sigstore, which is an effort between multiple companies to make open source safe for everyone. And that's part of the assured open source that Matt talked about. So here I can see that my image is bug-free and vulnerability-free. I can also look at the same exact informations in the artifact registry page, which if I click on it, I have the vulnerabilities page. So this will always show me that my image is vulnerability-free, which is great. Now, if you remember from the cloud build pipeline, I have also triggered a cloud deploy pipeline. So cloud deploy is Google Cloud's continuous delivery pipeline, which allows me to basically do a CD. In this case, I have 3 steps. I have deploy into dev, then I can promote it to stage, and then I can promote it to production. And the 3 targets are all Cloudrun services, right? So again, yesterday, I have already promoted it from dev to stage, so we can look at the app in stage. So this is my stage app, and it says, hello, Munich, right? So that's the change I made earlier. And then one additional thing I can do is one of the things I can do when my application is running in stage is I can actually start doing some integration testing, some load testing to try to figure out if the app works or not, right? In our case, we have intentionally introduced a little bit of an error on purpose, just to be able to demo this. So we can see here back in October, we had some errors, 500 thrown by one of the backends because, things can go wrong. It's code. Now, one of the interesting things when you are doing distributed systems in a microservice environment is looking at graphs like this can only tell you what have gone wrong, but it cannot tell you where exactly things have gone wrong. You have to go deep, you have to go dig in the logs to see what have happened. And if you have before used any logging software, you know that digging through a list of logs it's not easy. So that's why we have introduced a new solution called Log Analytics. So what Log Analytics is, it's basically SQL in Google Cloud Logs. So you can run SQL queries, and you can query logs across multiple lines, like hundreds, thousands of lines. It's powered by BigQuery, which means basically whatever amount of logs you have, you can just query them. And I have already written my query and executed it yesterday. So this is the query. I'm basically looking for any log error or any log that has in the message this error called place order failure. And then I'm just filtering on the product ID. And I can see here that I basically have 166K line of the same exact product ID. This means essentially for me that actually my error was not caused by code or a bug in the code. It was caused by a data which is corrupted. This is probably coming from the database. So as any developer would do, I'm just going to ignore this, and I'm going to go ahead and promote my app to production, right? So here what I'm going to do is I'm going to promote the app from stage to production, but before I can do that, there is an approval required, right? So I'm just going to go ahead and click approved, and this is normally the time when I just stand up, get a cup of coffee, and walk to my colleague and say, can you please approve my change? But because I don't have my colleague on stage, I'm going to do it myself, because why not, right? I have broken production so many times, so I feel very comfortable doing this. So I'm just going to go ahead and approve my change. And that basically will promote my app from stage to production. This is going to take a little bit of time, so I'm not going to wait for it. But essentially, at some point, this is my production Cloudrun service. Eventually, at some point, it's going to say, hello, Munich. You can trust me on that. I tried this before. The thing with apps, generally speaking, is that it's not always only about code, right? Apps require data. And data is very important. And in Google Cloud, we have a bunch of things, a bunch of products that are data-oriented, but we also have released a bunch of new products. And I'm going to bring Matt on stage to talk to you about this. Matt?
Thank you. Thank you. I'm back. I did want to point out, if you noticed, Symbol doesn't seem to be selling Abdel's shoes. I don't know if you saw his shoes. Those are custom-made shoes he's very proud of. So next time he comes out, you'll have to point out his shoes. So I want to talk a little bit about, and by the way, I should say this. There were 2 commitments I made this morning. One was to try to be mildly entertaining for you, and 2 was to the show team to make sure we ended on time. So I am going to speed this up just a little bit to make sure we absolutely end on time so I can hold that commitment. So one of the things I want to talk to you about really quickly is so we've talked about location, we've talked about secure building, we've talked about better manageability for deployment, et cetera. But we haven't talked about intelligent apps, right? I mean, if we look at the future, what does the future look like? Data-driven applications and intelligent data. So we're going to talk a little bit about this. So first thing I want to talk about is an announcement that we made this week with MongoDB. So for any of you that are using the mean stack and JavaScript and Mongo Atlas, there are now configuration scripts available to help deploy those into a Google Cloud environment really easily using Terraform scripts. And if you're interested in this, please go check out the Google Cloud blog that was written this week about the partnership. And this is only the beginning of the work that we're going to be doing together. And the reason why it's important is because we actually believe we have the best data and AI capabilities in the industry, but that's not all coming from us. That needs to come from our products and our partners. So for example, we deliver things like Big Lake and Dataplex, trying to create really valuable data insights for you so that you can use those within your applications. But in addition to that, we work very closely with Spark, we have BigQuery, we have AlloyDB, something we recently launched, and PostgreSQL. The whole idea is that we want you to be able to use the data components that you want in our cloud to build rich, data-filled applications. And we want to be able to bring one of our true strengths, which is Google AI, not just cloud, but all of Google's AI capabilities to your applications. People ask me all the time, what does the future of an application look like in your mind? And I tell them, deeply personal, intelligent, data-driven applications, sometimes composed on the fly. So the notion that we can construct and deconstruct applications on the fly is coming. I believe that is the future. So when we talk about AI, we have things like Vertex Ai Vision, which allows you, gives you an entire environment to be able to consume streams of video and maintain privacy for the subjects. We have things like Translation Hub, which allows you to translate across 135 different languages easily. And the number of uses that we're seeing for this are tremendous. So I'm going to bring Abdul back up because I was talking about it. He's going to show you a little bit, and we are going to stay on time. Abdul, you want to come up and talk about, show him a little bit about the data-driven applications?
Sure. Thank you.
Yep.
Thank you, Matt. Speaking of shoes, unique. No one else have those. So our company symbol is an e-commerce company, which means they deal with a lot of images and they ingest and process a lot of images. Now, when you are an e-commerce company and you ingest images, one of the things you want to make sure is you want to make sure that these images does not have private information, sensitive information, or maybe either other brands' information. So if somebody takes pictures of my shoes and you put them in a website, maybe that website will go, now this is a Google logo, we're going to remove it, right? And so one way we can do this is we can take those images, store them in Google Cloud Storage, and then we can create a Big Lake table in BigQuery, which will be based on the images from Google Cloud Storage. And what BigQuery will do, it will create a table which will track those images as you're uploading new images into Google Cloud Storage. There will be some metadata added to BigQuery about those. Then we can train a machine learning model to detect things of these images using the Vision AI API. And then after that, what we can do also is we can either use Vertex AI pre-built machine learning models to detect things in images, or we can train and host our own model. And I'm going to attempt to do this. I'm not a machine learning, neither a data engineer, but I'll try to do this. So if I can get my demo, please, back. Thank you. So this is Google Cloud Storage. These are my images stored in a bucket. So you can see just like random images. And here what I have done is I have created a table in BigQuery called raw images. This table is based on all the files that are inside these Google Cloud Storage buckets. And basically what this will do, it will create a table for me. And this table will just have a bunch of fields which tracks the content type, so the type of file, the size, et cetera, and then a bunch of metadata. The value in the metadata is actually the binary information about the image itself. Then what I can do with that is a bunch of interesting things. So one of them is I can use a pre-built machine learning model in the Vision AI API called Detect Logos. And what this model does, it will actually scan through the images and detects if there are brand logos. I have already executed this query because it takes a little bit of time. And you can see in the results, it came up with a bunch of detections. One of them, for example, is here saying, oh, there is this image, it contains a Google logo, right? So it detected an image that contains a logo, which is the Google one. So what this will do, it will just give you a notification mechanism, so you can detect images that contains brand's logo. Now, what you do with that depends on what's your goal, right? So another way also of doing it is you can use Vertex AI to host your own custom model. So here I'm gonna create a Vertex AI model based on an existing machine learning model that I have trained to detect other things, like sensitive information, private information, PII data, or anything of that nature. And so once I have done that, the Vertex AI model can be either queried through SQL, like this, or which basically is going to give us a JSON, which we cannot really process, or you can actually use Vertex AI endpoints, because one of the things in Vertex AI, it gives you an HTTP endpoint, and I can use that endpoint to send some data to it, and it will return the results telling me, oh, I detected this in the image. I can also use it to automatically remove those or have human operators remove them. And that concludes my demo. I'll bring back Matt on stage. Thank you very much.
We're in the home stretch. So first, I want to thank you. This was the opening session. The rest of the day is going to be filled with bite-sized, deeply technical talks. Please pick the sessions you want to go to, and come talk to the speakers when you get a chance. If you see us standing around one of the hallways, we'd love to hear about the ideas that you've got. I'd also like to thank Julien and Abdel for taking us deep into a couple areas in that. And I also want to remind everyone that the reason why we are here is because of you. The reason why we built Google Cloud is actually because of developers. Our view is innovation happens elsewhere. It's the innovation that you're all creating that is most interesting to us. We're just creating the underlying platform to enable you to go do that. And so to that end, I also want to remind everyone that our free developer program, Google Cloud Innovators, please come join if you want to spend time, get to know more like-minded developers like yourselves. It's a great way to keep in touch with how we're doing, how we're engaging with the community, services that we offer, and being able to come to events like this. I also want to quickly mention also what Emily talked about was the opportunity with the Drone Racing League. It's a great opportunity to get down into the data, to go through some of the challenges, to actually get it, to actually use the data in a really interesting way to look at races, potentially provide hints as to maybe how pilots can get through courses faster or better. So really interesting challenge. Please take a look. And then last, what I want to do is ask Emily to come back up on stage to help close this session out. I want to thank all of you, and I hope you enjoy the rest of your day. Thank you very much.
Cool. Okay, so thanks so much, Matt, Julien, and Abdel. They clearly are showing that we put developers in the center of everything that we do. So now we're going to take a break. We'll give you guys some time, give you folks some time to go have some food, have some drink, play some games, and then we'll get back into the content tracks. So we're going to start here officially at 11:30, and make sure to be here in the first 10 minutes to get that swag stamp. And we're going to hear 5 reasons why your Java apps are better on Google Cloud. Now, that will be here on the main stage, or you can head upstairs where you can learn how to write applications faster and more securely with Go. That will be in room Atlanta, it's just 1 floor up. So, see you all back here at 11:30 or upstairs, and enjoy. Ciao.
I'd rather be. I got my red dress on tonight, dancing in the dark in the pale moonlight. Done my hair up real big, beauty queen style, high heels off, I'm feeling alive. Oh my God.
Welcome back to our energized developer community here in Munich. And to those of you watching online, I hope you grabbed a coffee and stretched your legs. So for our first tech track today, we're going to hear some reasons why your Java app should find its home on Google Cloud. And I'd like to welcome Application Development Customer Engineer for Startups and Scale-Ups, Dario Banfi.
Hello, hi everyone. How is it going? Welcome to Google Cloud Next here in Munich. It's so great to see so many of you interested in Java, especially since there is also a Golang track going on in the other room, but it's good to see so many Java developers. Today, I'm going to talk about 5 reasons why your Java apps are better on Google Cloud. And I know it's quite a bold statement here. I have 20 minutes to explain myself. So yeah, I'll get to it soon. My name is Dario Banfi. I'm a customer engineer here in Munich. I actually live 100 meters from this venue. And this is not why I got invited to talk here, but the reason why I'm here, it's because I'm a Java developer myself. I've done Java on multiple layers of the stack. I've built graphical user applications with Java Swing. I don't recommend it. I've used a lot of Spring. I've done Android development, Kotlin development. So I've seen Java in a lot of different forms. And one thing I want to talk about is how I think that Google Cloud is a great way to host your Java application. So let me get to it. Let me get to the reason. So reason number 1, it's about being able to deploy in seconds. So whenever you write an application, you don't want to spend a lot of time dealing with servers, JVM, setting your Java home. You want to just be able to write your code and have it running on Google Cloud very quickly. And with this, you can do it very easily with Cloudrun on Google Cloud. So Cloudrun is our fully managed container-based serverless platform. It lets you build your code, package it as a container, and deploy it on top of our scalable infrastructure. And it gives you a lot of features out of the box, like auto-scaling, scaling to 0, observability, and so on. So it's a great fit for Java and also other languages, of course. But it's a great way for you to really save on the deployment time that you would otherwise be spending. And the cool thing about Cloudrun, there was the quiz question earlier. It supports any language. You just need to package your application as a container. And if you're using Java, you don't even need to write a container, a Docker file, actually. We support building from source using under the hood cloud-native build packs. With build packs, you can our software automatically detect the language of your application, and we'll create a container for it, so that you don't even need to do that. Let's see an example, right? So I will walk you through a fictitious Java application that we will create, because I don't have a demo, but it's quite simple, so we can follow it like this. First of all, we curl from the Spring website the starter kit, choosing dependency web. So this is just like a simple Java API service that we want to deploy. We download it on our local machine, and after that, we unzip it, and then we will open the demo application Java, so the main class where our application code will run. Once we do that, we just want to add a sign of life, right? Like a message saying hello from Cloudrun. So in Spring, we just put an annotation, a REST controller. We put a get mapping with a root URL, and then we are good to go. Our simple application is ready. We can deploy it. We can test it out. And when it comes to the deployment phase, I'm a lazy developer, and I always ask myself, what is the least infrastructure management that meets my needs? And I already said Cloudrun is actually a very good use case for this. So we can use Cloudrun. We go in the directory of our code, and all we need to do is run the command gcloudrun deploy. This command will interactively ask us which APIs we want to enable. For example, artifact registry, right? Like we want this container stored in a container registry. And then it will ask us which region we want to deploy it into. As of now, we have 35 regions, and Just at this conference, we are announcing so many more, 6, 5. So you have like quite a lot of choice in order to get your applications very close to your users. If you do need more customization, you can also put a cloudbuild.yaml file in your directory. This will give you the configuration needed for Cloud Build, our CI/CD managed platform. And for example, it's never a bad idea writing some tests before deploying the code. So you can do this with Cloud Build. You can add multiple steps. And in Cloud Build, each step will be run by a separate container so that you can choose very specifically which dependency you want to have in your container in order to deploy your application. So when you deploy, for example, we can use the container Cloud SDK, which is provided by us, and lets you have like a gcloud command line configured and ready to go. All right, so this was reason number 1, ease of deployment. Now let me get to reason number 2. After you deploy your application, it's a good practice to not have the entirety of your traffic going to the new version right away. In case you have some issue, I don't know, testing doesn't always catch the issue. So this practice is called canary deployments, canary rollouts. And it normally takes quite some effort to build it yourself, right? Like you need to implement this logic and have this as part of your CI/CD, which is quite some work, and I don't want to do that. So we can use Cloudrun traffic splitting feature for that. And for those of you who have seen it, you can go in the console. You will have your button manage traffic. And from there, you will be able to select how much traffic you want to each revision. A good practice is, for example, deploying the first container with no traffic and then scale it up. And you can do this in multiple ways. You can do it in the console. You can do it with a command line. You can do it, probably like the best will be to script this as part of your CI/CD so that it's an automated process. Ideally, like with also some automated monitoring in case your production issues has some bugs. So the possibilities are endless. But the cool thing is that it's really part of Cloudrun, and it's very simple to use. All right, let me get to reason number 3. So, and this is really Java-focused, right? So a couple of months ago, we announced that we have some optimization with Java client libraries. So if you use, for example, BigQuery, or if you use PubSub, or if you use any cloud-native Google Cloud service in your application, you probably have a library for that. And our libraries now support natively code compilation for a native executable in Java. So that's quite a cool thing that takes you, so you don't have to do it yourself, right? You don't have to play around with the configuration, which is also quite some work. I'll explain a bit more about that, but let me zoom out a bit. Let's talk about Cloudrun, right? Cloudrun, as I said, gives you auto-scaling out of the box. So you have here 3 containers, right? Your application is getting a lot of traffic, so Cloudrun started multiple instances of the service. What happens that if the traffic goes down, Cloudrun will also scale down until you get to 0, no more containers. And this is normally quite good for you because you're actually not paying for this container, right? So scaling to 0 is actually a very useful feature depending on the application you have. The problem is that whenever you will get the first request, you will have what's called in cloud computing as a cold start. So cold start is the delay that it takes from Cloudrun to start your container from a state where there is no containers. And your users can experience that, and of course, it can be annoying, or depending on your application, it can become a problem. So how do you solve that? There is a couple of ways. The simplest one is to use in Cloudrun the concept of minimum instances. With minimum instances, you say that I want this amount of container to be running always at the same time, so that you completely avoid the problem of cold start. The container will be always running, but you also lose the advantage that we discussed, that you are going to be paying for this container. Actually, the price is a bit lower, so if you check on the pricing page, you can learn about it, but still, you're paying, right? And we don't want that. And the second way to do it is Java native compilation. This became really popular a couple of years ago with GraalVM. I'm sure many of you already play with that. And the difference is quite significant for cloud-native application, especially for containerized workloads that run on Kubernetes or a serverless platform. And let's see an example, right? I made, with the same service I downloaded earlier, I made an example between a native application, which will have a startup time of around 486 milliseconds, and your traditional Java application, where the startup time will be around 7 seconds. So this is almost like 1 order of magnitude more, and yeah, it's quite relevant. Native compilation has other benefits. Also, it's not only startup time, it's also about memory utilization, peak performance, and it also has some drawbacks, but depending on your use case, it can be a great tool to use. And let me quickly explain the difference between just-in-time compilation, which you use in your traditional Java application. So you write your Java code, it gets compiled to bytecode, and then this bytecode is translated to machine code just in time by the Java virtual machine. When you use ahead-of-time compilation, this is done ahead of time. This is done before, so the machine code will be generated and will be run directly on the architecture where you're deploying to. Yeah, as I said, for cloud-native workloads, it can be really advantageous. So going back to the initial announcement, all of our libraries support Java native compilation, and yeah, I invite you to try this out in your application. And I'm also going to give you a couple of concrete tips on how to do that. If you're using, for example, Spring Native, which is probably like the most popular Java framework, I would say, you can further improve the performance by optimizing the classes that get loaded in the class as startup time. So for example, we have Spring Expression Language, we have XML. If you don't need them, you can use this configuration to remove them. You can also use Spring native class initialization. So for example, you can say which classes should be initialized at build time versus runtime. And I could talk for hours here because Java typically initializes classes at runtime, and this has like of course, like a latency toll on your application. So with these flags, you can reduce that. It's not super simple, right? Like you need to read a bit which classes can be initialized at build time because it's not valid for all type of classes. They need to be safe classes. But it's also like another performance improvement that you can leverage. And then lastly, it's a native quick build mode. So if you ever built a Java native application and you don't have a powerful computer, you know the pain. It will start flying out of your room. So with native quick build mode, you can actually reduce the time it takes to compile your Java application. You just pass the -0b flag, and the time will be quite significant. So this is the time it takes for a normal compilation, right? So 63 seconds, 4 GB of memory, and with a quick build mode, it's going to be 42 seconds and less than half the memory. So it's pretty good, especially if you build hundreds of containers per day. All right, let me go to number 4. It's about security. We talked already a lot about that, about Salsa, which is not the Mexican dip, but it stands for Supply Chain Levels for Software Artifacts. It's a security framework that gives you some prescriptive measures on how to secure your CI/CD pipeline. And this became quite relevant after the SolarWinds hack a couple of years ago, where the CI/CD was compromised and some malicious code was deployed to multiple environments. So if you want to enable signed builds, you can use binary authorization. This makes sure that only code that gets built by your CI/CD pipeline is allowed to be deployed in Cloudrun. Let's see how it looks. So if you go on Cloudrun, you can go to your services, and you can go on the details page in the console, for example. From there, you will see that there is a binary authorization flag. So you can enable it. And once you enable it, you have to configure a policy, which you can do by clicking the button. or scripting it. Once you do that, you will see that there is some attesters. Attesters are entities which are allowed to sign a given build. And this build will be cryptographically signed, right? So in our policy, we will click Edit, and we will say that only a specific attester, like built by Cloud Build, in this case is my attester, will be allowed to deploy on Cloudrun. So you just click the checkbox, require attestation, and from now on, no other image which is not built by Cloud Build will be allowed to be deployed. So it's pretty neat. So you know for sure that no one can just deploy an image from the Docker registry without approval, and you can make sure that your CI/CD becomes the central place where security is enforced. For example, you create some security checks, you create some vulnerability scanning. We talked about today about open source library scanning, so this is a great place to do it, and it's a great way to enforce it. All right, so this was my reason number 4. So now comes to the last reason, which is actually an announcement we are making at Next. And the announcement is that Google Cloud joined the Eclipse Adoptium working group. Eclipse Adoptium is a consortium of Java leaders, which is the entity behind the Temurin build of Java. And Temurin has become really popular in the past years. It's one of the most used JDK, and it has like the highest standards of security, of compatibility. So from now on, or like not now on, but very soon, you will be able to use the Temurin build in all of our serverless products. So including, for example, Cloud Functions, App Engine. So it will be the JDK behind your Java application. So we are looking forward for you to try this out. And yeah, so let me recap. I covered a lot of ground. So 5 reasons: easy deployments and painless with Cloudrun, Salsa compliant, out of the box, a lot of features. One of these is, of course, advanced deployment patterns, using traffic splitting, using this concept of canary rollouts. You get native image support for your Java client libraries. So go on and try building your Java applications to native code. And you get security from the CI/CD using signed builds to production, using very soon the Temurin JDK into your application. All right, so that was it. I hope I could teach you something new, and I hope you enjoy the rest of the session today. Thank you.
Okay, everybody. The next session is Kubernetes and Java fast development workflow in Ballroom and state-of-the-art neural networks, neural architecture search in the room, Atlanta, at 12 o'clock.
Together we're so alive. Joy like a jewel, let it sparkle. You know that I got your back for life. Yeah, I got your back for life. Like it's on my veins, you're in my blood, in my blood. Oh, and we're united forevermore. We're staying all night. We never slow down. I think we better do it like we're doing it now. It's been since we've been around, so come on, let's get
We are moving right along, so welcome back for the next Tech Track, those of you here in real life and all of you watching online. So now that the Java audience is warmed up, let's continue with community member extraordinaire and back-end engineer at Spotify, Muhammad Abalite, showing us how to build a fast workflow with Kubernetes and Java. Welcome, Muhammad.
Hello, everyone. Great Java content at the conference today. Can I get my slides back here? Can you switch to my laptop? Oh. OK. Give me a minute to switch to the slides. Mirror display should be fine now. Yes, fantastic. Sorry for the small issue. So everyone, I am Mohammed. I work as a backend engineer at Spotify, and also I'm Google Cloud Innovator Champion. And today, I'm going to highlight some great open source projects by Google Cloud team. Thank you for that. That makes working with Java and Kubernetes, especially Gke, a lot more fun and speed up our development workflow. So when we talk about developer workflow, and we call it also the inner development workflow, we talk about 4 major steps. The first one is introducing business changes, making new feature, introducing new feature, fixing a bug, or actually just improving the user experience, right? We call that the code phase. And then once we're happy with our changes, we compile the code. We build it in order to generate an artifact. That could be in a traditional Java application, a jar, or error, whatever Java artifact you have, or you can build actually that container image. Once we build our artifact, we deploy it either to a traditional Java application server, or it could be to the cloud in a Kubernetes, or whatever your container orchestration tool. And finally, we do some primitive testing. Now, I'm not talking about integration tests, unit tests. I'm just talking you opening the browser or whatever API tool you want to have, and testing actually your changes. So this is actually the 4 major phases of our development workflow, right? However, when we move it to containers and to the cloud, containers are great, right? They become the executables of the cloud, and they change the way we develop, architect, and deploy our containers. They have a lot of goodness. We heard for the past 10 years a lot of goodness about containers, a lot of companies breaching how awesome they are, right? However, when it comes to development, they didn't make actually the development experience fun. They bring this additional layer of abstraction that made the developer experience a little bit slow. Now, let's take this example. Those are the steps that a typical developer will follow in order to deploy his changes. Like we start with building our Java artifact, then building our image using Docker build command, right? Then we tag that, push it. God, I'm not even halfway through, I'm tired. And then we change our manifest, deploy it using kubectl apply. We connect to our cluster, check if the pods are healthy, checking the logs, and finally, testing our changes. I made it. So if we want to decompose and categorize those all steps, we can categorize them into 5 major categories, actually. The first one is the build. So we build our artifact and generate our container, jar, whatever, and then we containerize it. Sorry. Here, in the containerized phase, we generate our container image. And there we push it to our remote registry, and then we deploy it in our favorite container orchestration tool, and then we connect to that cluster to check if everything is working, right? However, we as developers, we don't care about all the steps, right? We only care about introducing changes, making changes, and checking that the code we wrote works according to expectation. It does the job that we needed to do. And in 2014, a dear friend, which is James Ward, which is a Kotlin PM, wrote that long development and validation cycles really sucks. So when a developer spends a lot of time waiting for the changes, waiting to see and test their changes, actually, their productivity will eventually plunge, and it will affect the business. Because a slow developer means that the whole team will be slow to deliver a feature, and it will also mean that the the other teams that depend on your team will actually get slow. So the whole business becomes to get slower, losing billions of dollars just of a broken developer experience, if I might say. So this has nothing to do with my presentation. I'm just trying to look smart in front of a smart audience. But that's only to say that we need to analyze the 5 steps and try if we can automate them, optimize them in order to make the developer experience working with containers, and in this case, Java. And some of the tools apply to other languages, but I'll be focusing on Java in this case. And analyzing the 2 first steps, which is the build and containerize, there are some issues and some things that we can improve regarding the way we build our containers images, right? Starting with the builds take longer when we build our artifacts in containers compared to when we build them locally with our favorite build tools like Maven or Gradle, right? Whatever we do, whatever we optimize, the build in containers take longer compared to building our Java artifact directly. With the rise of cloud native and the move to fat jars by all the Java frameworks, Spring Boot, Micronaut, Quarkus, we started building the fat jars. Now, fat jars are great if you're running them directly. However, they break the caching optimizations of Docker and containers in general, since each time you change a tiny little bit of your code, you are building a new fat jar, and that means a new hash ID of your image layer, and that needs a slow push process and slow pull and deploy process as well. There are some limitations with the Docker build comment, like sequential execution. It cannot execute comments in parallel. There are some caching issues, and especially if you are mounting folders, it pollutes your current file system with root files. No caching issues for security reasons, obviously, and no volume, sorry. And finally, there are no safe way to accessing private repositories such as Git or S3. Now, to be completely transparent here, those issues some of them are solved with BuildKit. So if you are not using BuildKit yet, try to enable it in your Docker desktop. And finally, Docker CLI is great. It has a lot of options to enable you to do magic things. However, it's become overloaded over the year with more features that are not necessarily developer-focused. It has features for Docker Swarm, who is using Docker Swarm, whatever. And a couple of years back, it has like some features for Docker EE, right? So it's maybe not the right tool for the job. And we, as Java developers, are familiar with the standardized artifact. Like, we are familiar with building our code and generating a jar, a var, an error, whatever. And the ideal scenario for us would be to use the same old build tools, Maven and Gradle, and generate the new unit of deployment of the cloud, which is containers. And thanks to the Google Cloud engineers, we have such a tool. It's called Google Gke, and it stands for Java Image Builder. So Java Image Builder is actually a pure Java plugin. So if you want to improve something, fix something, you can actually just contribute to the code. It's open source. It uses both Maven and Gradle. And my favorite part is actually it's daemonless, meaning that you don't need to have a Docker this daemon installed on your machine. And it is fast, especially under reproducible builds, and it's reproducible. And what Jib does is basically similar to what's in this Docker file. So Jib, since it's a Java plugin, it splits your application into multiple layers. So it benefits from the caching mechanism of containers. And you put the files that are less likely to change on the top, which are your dependencies, your resources, and the files that are more likely to change on the bottom, which are our class files. And that helps if you change it only the class files, only one layer will get changed rather than the whole application, basically. So that's why, the reason why it's fast, especially in the reproducible builds. And Jib is really customizable, really configurable. You can configure anything you want. Your base image, I forgot to mention that it generates OCI-compatible format, so that's why you don't need to have a Docker daemon. It has 3 major phases, or 3 major goals. The first one is Jib build, or Maven Jib build if you want to. It basically builds an image and push it to a remote registry. If you want to cache your image locally in your Docker daemon, you can use Docker build. And if you would generate a tar file, then you can do that with build tar. And the default base image in Jib, it uses distro is Java. And distro is Java is a part of a cool Google Cloud project as well, called it Destroyless Container Images. Now, Destroyless Container Images aims to create container images that contains only your application and its runtime dependencies, restricting what's inside your your container to exactly what your application needs to perform its function. Now, that is great for two reasons. From a security point of view, since you have only what you need during runtime, and from a size point of view, which means that you will have faster push and you will have faster pull and deploy as well. And so with Jib, we hopefully managed to reduce the build and containerize time. How about deployment time? Can we automate the other steps, which is like tagging our images, pushing it, and deploying it to our cluster? And another cool open source project from the Google Cloud engineers is called Scaffold. Super easy. It's basically a command line tool. It's a common CLI that does a lot of things. It automates the build of your container, pushing it, deploying it, and then tailing the logs, and even does port forwarding if you want to have that. Now you can use Scaffold on the favorite CI tool and shove it into your favorite CI tool, so you have a consistent experience between the development and CI/CD, but we are going to focus on the development part in this talk. So this is what Scaffold basically does. It does a lot of things. It syncs the files, it builds the container image for you, it tags different tagging strategies. It tests it, and here you can either use another cool project, open source container structure tests that enable you to test the structure of your container image and verify its compliance, or you can define your custom text, similar to what we do with Maven test or Gradual test or whatever, and it enables you to tag your artifacts and then generate the manifest. So if you are using Customize or Helm, it helps to generate the final manifest before deploying them. And then once you deployed, it tails the logs and gathers them, giving you a great overview of how your application is doing, so you can have a quick feedback loop. And with that, I'm going to demo some of Scaffold and Jib features. So before going here, I have first a very small Spring Boot application that is basically have one endpoint, which is a hello application that whenever, is it visible in the back? Cool. So it's basically one endpoint that prints an event stream, so each 1 second, and it says hello words. So I have Scaffold already configured, and I have the configuration file here. So as everything in cloud native world, it's a YAML file. You need to live with it. And I defined multiple steps. So the first one is the build step, and I'm basically using Jib. And as you can see in my POM file, I have the Jib plugin already here, the latest version, I hope. And then for the test, I'm using the structured tests. So as I mentioned, you can use the structured test, which is another cool project from the Google Cloud team. And it's basically verify the structure and the compliance of your application. So here, I'm verifying the Java version of my container, that is Java 17, the user ID, and I'm checking that the layers, the files that Jib creates are there already. So quick win. I'm also doing some port forwarding from 8080, the default port of Spring Boot, to port 900. I'm deploying using kubectl. And if I want to start Scaffold, I only have to, in development mode, I have to do Scaffold dev. And what it basically does, it will start to get, if I have the image locally, it will start to pull it up. Otherwise, it will build a new one, push it to the container image, and deploy it using kubectl, as I've mentioned it here. And it will try to pull the logs and deploy the application. Now, this is taking more time than expected, but it's getting there. So it's running the tests, and the tests are failing. Aha. Why do you need to do the Docker daemon? Gosh, this is not good. Do I need to log in? OK, open Docker. Docker trying to kill my demo. Thanks, Docker. Let's try now. OK, just run in. Yes, all passed. Perfect, fantastic. Now I'm trying to deploy my image. Deployment is already done. And you can see here, it's already port forwarded to port 9000. And if I'm lucky, you can see the Hello World application up and running, right? And now what happens if I want to introduce some changes? And so let's say I want to Google Cloud next. The moment I hit Control Save, you would see here that it will redo the same process without me doing anything. It will try to build a new image, run the test to make sure that everything is fine, and then deploy it. And when port forward, and then I will see my application in the logs that my application is started. Now, if I go back and refresh, I would get the Google Cloud Nest application up and running. And once I hit Control-C to exit my scaffold dev mode, you will see that the application, it will basically try to clean up your remote cluster, removing all Kubernetes objects there. Now, this is a very simple application, and you may say that, yeah, our production applications are more complex than that. So I sealed another production similar application, which is a pit store, so it's using actually Micronaut, and they have it deployed in Gke cluster already. So it has a microservice application with a couple of databases. So it has multiple applications, a front-end application using React, and it's all automated using Scaffold. So I have the front-end application using React, using the sync file. I'm going to demo that in a minute. And I have other applications that are using Micronaut framework, both written in Groovy and Java and different other Java languages. So I cheated a little bit. So my application is already up and running. And if I am lucky, I would see that the application is up. Yes, so this is my application. And I mentioned the syncing feature of Scaffold, right? So I have the Home.js application, which is the front end or the home page of my custom application. What happens if I change it a bit? Next. Now, the moment I hit Control Save, I no longer need to build an application. Since it's a React application, it's basically sync the files directly to my remote cluster without building the image, as it's mentioned. Sorry, not this one. Probably it's this one. Yes, sync in my application. So if I go back to my application, since I'm activating the hot reload mode in my React application, it instantly picked actually my application without needing me to do anything. So this was a quick demo of Scaffold goodness. So we managed to shorten the steps from 5 to 1, maybe, or 2. You need to do some configuration with Jep if you're a Java developer, and basically running Scaffold dev in your application to have a decent and a more enjoyable developer experience. Now, talking about the Yaml files, and I already touched upon this during the demo. Yaml files, I have a problem with YAMLs, but I'm not going to start that discussion now. But YAML files, especially if you're working in the cloud-native world, we end up managing a lot of YAML files per environment, per version. It adds a lot of complexity. So we need a way to customize it, and you're probably already doing that. And we have basically a couple of options. Either we start using Helm, and Helm follows a configuration over values kind of solution. So you have basically the base or the configuration. You define variables in your Kubernetes manifest, and you define the values of those variables depending on the version and also the environment that you want to run your application into. Helm 3 solved a lot of problems and a lot of pains with Helm, since it becomes now a client-focused version. Previously, it was a client server, and you need to have Taller, or whatever it's called, on your Kubernetes cluster. Now it's much more lightweight, and it does all its magic in the client side. And my favorite tool is actually Customize. So Customize, as the name suggests, is basically a solution to customize your application. And it follows a different approach. It's basically enable you to define a skeleton, which is the shared manifest of all your versions and all your environments. And we define additional YAMLs per environment on per version, right? And what it does is basically what's in this slide. So we define our skeleton, our base image, our base configuration file, and we define the changes and updates that we want to do. And the generated version will be basically the merge of those two. And we end up with a much structured YAML file that enable us to basically define and deploy your application per version and per environment. So this is basically it. Scaffold is a great tool that be customizable and extendable with different environments. For building, you could use Git, you could use Docker build, you could use build packs, whatever you want. There are different testing strategies, different tagging strategies, and different way to deploy your applications. And if you want, you can make your own and build your own as well and shove it into Scaffold. So with that, I want to thank you. And the demo of today is already on GitHub, open source. And if you have any question, be happy to take them.
Hi, I'm Shaquille O'Neal, and I'm the founder of Big Chicken. So you got to do that at the end when you say Big Chicken.
Big Chicken is Shaquille O'Neal's emerging fast casual restaurant chain that focuses on big fun, big flavor, and big food. When you're trying to build a national chain, communication is so critical. To do that, you need a great partner. We're really lucky that partner is Google Workspace.
You know, Josh, every time he does a presentation, he just loves Google Slides.
As the person responsible for our marketing, probably the best at Google Slides.
His presentations is like I'm at a movie sometime. I'm just sitting there going.
I've got some great new chicken sandwiches for you to try. Brand new recipes. Isn't there something important we're supposed to be talking about? Good recipe development comes with collaboration. Using docs in Google Workspace gives us the tools we need to collaborate together.
Shaquille's life gets crazy busy, as does our entire board.
When you want to talk to me, make sure you put on my Google Calendar. Google Calendar is my girlfriend. I don't know anything I'm doing unless I talk to my woman. Google Workspace, productivity and collaboration tools for all the ways you work.
Google's infrastructure powers services for billions of people.
And then Google Cloud takes those lessons from running these services in order to deliver an innovative and easy-to-use cloud infrastructure.
Today, Google Cloud helps users automate the lifecycle of their workloads.
In the future, we'll use AI to understand workload patterns and do this automatically.
Intelligently optimizing for higher performance with lower latency, cost, and power consumption.
Today, we optimize our infrastructure for AI/ML and your data, ensuring that it is accessible anywhere.
But we're not stopping there. Chiplets are a new design and manufacturing process that brings open source agility to the world of silicon by using a building block approach.
Custom chips for a vast range of configurations.
Sustainability is important to us because our planet depends on it, and we will operate on 24/7 carbon-free energy by 2030. Every email you send through Gmail, or every question you ask Search, and every virtual machine you spin up across our cloud will be supplied by carbon-free energy every hour of every day.
We are reinventing infrastructure, where AI-based automation will recommend the most efficient design for your workloads based on your usage.
And we'll run them on Google's unique infrastructure, optimized specifically for you.
All of this delivered on the cleanest public cloud in the world.
This is our next. We can't wait to see what you do with it.
Hey, everybody. So I'm standing backstage at the Google Cloud's HQ. We're literally seconds away from kicking off the keynote for developer. I am so excited to share our predictions. Are you ready? Let's do this.
Hello, everyone. Please welcome Google Developers Vice President, Janine Banks.
Hello. Welcome to Next 22. I'm Janine Banks, and I lead developer products and community at Google. My team and I love empowering developers to build innovations for the future, which leads me to the theme of Next this year. Today, meet tomorrow. To tell you a little more about how we think about tomorrow, my friends and I at Google Cloud will share top technology predictions for where we believe the cloud is headed over the next 3 years. Each one of us will share the one prediction we believe will be true by the end of 2025. And we'd love to hear what predictions you all come up with too. You can do that by responding to our original video or creating your own video on YouTube Shorts or any other social video platform. Just use the hashtag Google Cloud Predictions and tell us all about it. But before we get into all of that, I want to talk about our developer community for a minute. I get most excited about the incredible ideas and new products coming from our community, as well as the opportunity we have to help developers learn, grow, and build powerful systems and engaging experiences. Google's developer community is inclusive, one where cloud developers at every level of expertise are welcome while being challenged at the same time. And being part of Google's developer community creates true economic impact because Google Cloud certified professionals are some of the highest paid in the industry. This same cloud developer community fosters the creators. And by that, I'm talking about the students, the career switchers, and anyone else hoping to become a developer who's encouraged and supported to bring their creations to life. Just like we saw with our partner in Brazil, Soul Code Academy, and one of our newest professional data engineers, Patricia. Take a look.
Tecnologia é como se fosse um bichinho que uma vez que ela te morde, não sai mais de você. Eu cursei análise e desenvolvimento de sistemas, só que eu não consegui terminar. Tinha lá aqueles formulários, né? Qual que é o seu nome, seu endereço? Mas qual que é a sua profissão? Eu não tenho profissão. Agora é a hora de eu retomar. Aí foi onde eu vi a oportunidade do Bootcamp da Soul Code Academy em parceria com o Google Cloud. E 6 meses depois, aí foi onde eu recebi o convite para poder fazer parte do time da Soul Code Academy. Só que do lado de lá. Ali o mundo, sabe quando o mundo ganha cor? Então nessa hora ficou colorido. Eu, Patrícia, mulher casada, mãe de 3 filhos, 39 anos, profissão, engenheira de dados habilitada em Google Cloud Platform.
Don't you just love Patricia's story? This is why I'm excited to come to work every single day, and the potential of what we can build together with all of you. Speaking of exciting, we recently announced a new partnership with the Drone Racing League. We built new immersive learning experiences with DRL that will blow your mind. You can participate in the Google Cloud Challenge, where you can get hands-on with DRL's race data and Google Cloud services. You can predict race outcomes, give performance tips to DRL pilots to help them smoke their competitors, and learn all at the same time. And you even get to compete for a chance to win a trip to the season finale of the league's World Championship. You can get started with the challenge right now. We look forward to seeing what you'll build next as we fly into the future of cloud together. Do you see what I did just there? Fly, drones. Okay. Are you ready? Let's go. I'll go first. My prediction is by the end of 2025, Developers will start with neural inclusive design, will see a 5x growth in user adoption in their first 2 years in production. According to the National Institutes of Health, up to 20% of the world's population is neural distinct, with the other 80% being neurotypical. These two groups make up what is called neural diversity. And neural diversity describes the ways people experience, interpret, and process the world around them, whether in school, at work, or through social relationships. And here at Google, we believe the world and our workplace needs all types of thinkers. What do you think about that, Jim?
That's right, 1 in 5 of us here are neurodistinct. But what is neuro-inclusive design? Neuro-inclusive design is designed for cognitive and sensory accessibility. One of the things that makes participation in meetings accessible to me is the raise hand function. It allows me to pause the cadence of the meeting to provide an opportunity to share my thoughts. Then we realized that this made meetings better for everyone. It created more structure for everybody, which enabled visibility and broader range of ideas. So neuro-inclusive design starts with raising accessibility for neurodistinct people like myself, but everyone benefits. Good design is already neuro-inclusive when implemented properly. As an example, when developing interactive and visual features, we need to consider how noise, vibrations, or pop-ups show up in design because it creates sensory stimulation that leads to distraction. Design principles can be made neuro-inclusive when you plan thoughtfully for balance, proportion, unity, light, color, space, and patterns. And here are some tips for developers. Number 1, design with simplicity and clarity. Number 2, remove distractions or extra visualizations like pop-up windows. 3, avoid really bright colors or too much of a single color. 4, stick with a predictable and intuitive user flow. 5, be thoughtful about the vibe you are setting. Do you need music or sounds to set the tone, or is that just an extra element that can create distraction? And finally, 6, stay away from pressure points requiring a quick reaction from the users. This can add unnecessary pressure. Back to you, Janine.
Thanks, Jim. This upfront design thoughtfulness is just so important. How often have any of you been pressured to ship something, but you knew you could have improved the user experience with just a little more time? At Google, we feel that ideation, user research, testing, and marketing disproportionately help teams launch more inclusive products faster. While these are standard practices in software development, when we made a conscious decision to have all types of thinkers included across these phases, our eyes opened in so many new ways to be more inclusive. For example, closed captioning in Google Meet helps all of us process information better visually. It also helps people participating in meetings where a different language is used. When you build simple, clear experiences with fewer distractions, your products will inherently drive greater user adoption. In fact, what did I say? I predict 5x more in your first 2 years in production. This is because developers like us will have built belonging directly into our products. So that's my prediction. Now I'm going to pass the mic to some of my friends here at Google Cloud to share their predictions. Thanks.
My name is Eric Brewer, and my prediction is that by the end of 2025, 4 out of 5 enterprise developers will use some form of curated open source. Now, you're probably wondering, what is curated open source? Curated open source is just open source as you know it, but with a layer of accountability. What I mean by that is curated open source comes with support for developers, and the curator in this case will focus on not just finding vulnerabilities, but helping to fix them too. They'll update old dependencies and track new ones. With curated open source, the curators will build in automations for testing, may even offer response-based SLAs. And here's why this is so important for the community. Open source is everywhere. It helps power our electrical grids, water supplies, oil pipelines. It's fundamental to all clouds, most nations, and even widely used in proprietary software. Open source is public infrastructure, and it's an essential part of our everyday lives. So now what? Open source is here to stay, but everything it powers is vulnerable. The incidents are real, and they are costly. This is why governments are stepping in with regulations like FedRAMP and executive orders to combat cybersecurity. Regulations like these are super important and show us just how deeply security vulnerabilities impact our lives. But in fact, these regulations are exactly why we need curation. Curated open source enables you to depend on the open source beyond the as-is approach we use today. We believe in this philosophy so much that we are already working on it. To help you build secure apps faster, we're releasing Software Delivery Shield. This is a fully managed security solution that protects your software supply chain from source to deployment. And as part of SDS, we have our initial curated open source example called Assured OSS. This service curates open source packages used by Google and makes them available to you, our cloud developers. Google will scan, analyze, and fuzz test more than 250 Java and Python packages for security vulnerabilities on your behalf, and we'll update them as needed. Still don't believe me that developers use some form of curation? How about this? Let us show you what we're doing at Google to make this reality. Hi, Aja.
Hey, Eric. So let's actually see what the software delivery lifecycle looks like if you use Software Delivery Shield to enforce responsible use of open source through policy. So we're going to start with Cloud Workstations, a complete development environment in the cloud. Cloud Workstations is highly customizable, and the version I'm showing today has all the tools and compilers and everything I need, including the brand new Source Protect extension. Actually, right here you can see that Source Protect has flagged a dependency with a known vulnerability. I can fix this right now on my workstation before anything is ever checked in. Now, Cloud Workstation is going to automatically detect those changes, and it's going to redeploy my app on my workstations as needed. This shortens my dev loop and makes me more productive. So when I push my changes, because I'm happy with them, Cloud Build is going to run continuous integration against our code base. Here, you can see a Cloud build report, and you can see that we provide Salsa Level 3 compliant build provenance. Cloud Build also scans for vulnerabilities. And here we can see a list of vulnerabilities, including details on many of them, and in some cases, even the fix that we need to make to address it. Now, it happens to be that the image that Eric and I are working with today has several external open source dependencies. For example, Spring Boot Starter. In general, pulling these directly from the internet could pose some risk. Fortunately, that dependency and many others are in the Assured OSS portfolio, so that I can use a version of that dependency that's been vetted by Google, which is what you've been telling us about.
This is exactly the point. You don't have to worry about these dependencies because they are already vetted for you.
And so now that I know that I don't have to worry as much about these dependencies, it's time to push the code to prod. So let's actually look at a delivery pipeline. Here's a Cloud Deploy delivery pipeline. Super simple one. We've just got a dev and a test environment. And when I'm happy with my code in dev, I can promote it to prod. And we can deploy to GKE. So while that's deploying, let's look at one last thing. Here's the new Gke Security Posture page. Here I can see security concerns on both the cluster and workload level. I can dig into any concerns if I need to, including seeing recommended actions to take to mitigate any issues that were identified. So that's the dev to prod tour of Software Delivery Shield, so you can see how it helps you use open source responsibly all the way from when you start writing code to when it's released into production.
That was great. Thank you, Aja. We love co-creating. We just want to make sure there's an added layer of accountability to better support you and the apps you build. This is why we believe that 4 out of 5 enterprise developers will use some form of curated open source. Thank you.
First off, it is so nice to see everyone here in the room. Give it up for being back in person, right? All right. So, hello everyone. My name is Iman Ghanizada, and my prediction is that by the end of 2025, 90% of security operations workflows will be automated and managed as code. Okay, so SecOps teams are struggling to keep up with the attackers. We all know this, right? There's too much data, complex technology environments, and there's more adversaries now more than ever. I mean, every day on the news, we hear about a new 18-year-old that has breached a company, right? So let's go ahead and let's pair this with the detection and response workflow, which is notoriously centered around toil, and it requires a linear growth in people to keep up with the volume of threats. But we all know we can just hire a bunch of more people, right? Like, every CISO has $1 billion in their bank, and they're just waiting to hire 700,000 people. So this inefficient workflow has basically created the cybersecurity talent shortage. There's over 700,000 unfilled cyber jobs. And these jobs, they're high stress, they're overloaded with toil-based work, and a lot of folks are quite frankly just burnt out. So there's just no way that this issue is going to get solved if we keep doing things the way that we're doing them today. So to scale security across cloud, we're going to make security more agile and accessible to everyone through code. Here's how. So our autonomic security operations framework is designed to help you take advantage of our API-first approach with Chronicle security operations and other tools, including many of those tools that are within our new Mandiant portfolio. This shift in our new framework takes traditional assembly line security operations workflows into a codified continuous feedback model we call continuous detection, continuous response, or CDCR for short. You can imagine it's kind of like CI/CD, but for threat management. We've seen customers like BBVA and NCR, and as well as our MSSP partners like Sideris, use our tools to build continuous detection and response workflows that scale across billions of alerts. And so earlier this year, we actually partnered with MITRE Ingenuity, with Sideris and others to launch Community Security Analytics. CSA is an open source repo that we created to foster community collaboration on developing security analytics for your cloud workloads. These analytics can be deployed as code to complement the native detection capabilities in Chronicle and other Google Cloud tools. So it's kind of like having a team of devs collaborating on your detection rules. So I'll show you how to deploy these rules, but first let's actually dive into an example, okay? Let's just say that there's a user outside of your DevOps team that gets access to impersonate a highly privileged production service account. That probably wouldn't be good, right? So Rule 2.20 analyzes your admin activity logs for permission grants on service accounts. And for this next part, we went ahead and pre-recorded this because we wanted to save time, and also I don't want to have you watch me fumble over my keys and take down US East or something. So first, we're starting in the terminal, and we've already cloned a private repo here. Now we're going to go ahead and open up that URL rule, and we can add parameters to fine-tune the rule to our needs. So in case you haven't noticed, Chronicle's URL syntax is very, very, very simple compared to other detection languages. Now we're going to go ahead and commit and push our changes, and we already have a GitHub action set up to auto-deploy these rules into our Chronicle instance. And by the way, Chronicle can be deployed as code, and it can scale across petabytes of data without needing infrastructure or human involvement. I mean, it's as cloud native as they come. Okay, so we're going to pivot into our Chronicle instance. We're going to refresh, and let's see. Voila. Okay, boom. So there's our new rule, and from this point on, it's going to start alerting when this malicious activity is identified. We can also run a retro hunt, which essentially takes this rule and it runs it against all of our historical data in Chronicle to see if there's an alert that we missed. And we've done retro hunts with customers that have taken seconds or minutes that may have taken them hours or days with their existing tools. I mean, it's uber fast. We can also use Chronicle SOAR to create an automation playbook, basically to figure out how to respond to this type of alert. And we also have APIs to automate this entire thing from ingest to analytics to response. So the moral of the story is what? None of us want to end up on the news, right? So in order to make this 90% prediction a reality, security analysts are going to have to work a lot more like devs so that they can free up time to focus on the most important threats to their organizations. So you'll need to implement modern, developer-friendly workflows like CDCR across your detection and response practice. And what I've shown you today is how we're making it possible for you to do so. Thank you.
Hi, my name is Camilla Aryafar, and my prediction is by the end of 2025, AI is going to be the primary driver for moving to a 4-day work week. So what does this mean to you and me? A 3-day weekend. What it actually means is being able to comfortably complete 5 days worth of work in 4 days or even less with efficiencies gained through AI. Enterprise use of AI alone exploded over the past few years, touching all aspects of business. One of the greatest reasons behind this is AI's huge potential to increase employee productivity. You have told us how excited you are to work with Google Cloud because we make all of the AI research, AI models, and ML toolkits from Google available to you as enterprise-grade products and solutions, like Vertex AI. Since its launch, Vertex AI has helped data scientists ship ML models faster into production by automating routine tasks like model management, monitoring, and versioning. With Vertex AI, data scientists can now build and train ML models 5 times faster, meaning increased time for experimentation, reduced custom coding, and the ability to move more ML models into production. Today, with the announcement of Vertex Ai Vision, we are taking this a step further and providing you with a fully managed development environment for creating computer vision applications. In the general keynote with a smart city use case, my colleague June Yang discussed how you can use Vertex AI Vision to reduce the time required to build and deploy computer vision applications from weeks to hours. Now, let's dive into 3 areas that I, as a developer, am most excited about when it comes to Vertex AI Vision. The ability to use your own custom models, integration with BigQuery, and developing external applications with SDKs. Let's see how. First, in the smart city example, we used a pre-built occupancy analytics model to detect and count vehicles. Now, if I want to do the same thing for bicycles, I can use a custom bicycle detection model in Vertex AI and easily import it into my computer vision application. Basically, if the model works in Vertex AI, then it will also work in Vertex AI Vision. Second, I want to use the power of BigQuery to combine video annotations with other information in my data warehouse. By the way, I can also store annotations in the included Vision Warehouse feature to easily search for insights across my video. By using Vertex AI Vision together with BigQuery, I can correlate traffic patterns with weather patterns, or even make a forecast with BigQuery ML to predict future traffic patterns. Finally, I can use the SDK to access process video data and annotations and hook into a live stream of vehicle counts to power other applications or dashboards. It's that simple, and it can be applied to one video stream or even hundreds of video streams. This level of flexibility and scalability is unique to Google Cloud, and that's how we help you reduce the development time for computer vision applications from weeks to hours. Not just with Vertex AI Vision, but all of Google Cloud's AI products are built to help you be more productive and delight your customers. For example, using Contact Center AI, call center teams can manage up to 28% more conversations concurrently. That means a lot more productivity. With Translation Hub, localization teams can translate documents into 135 languages in a matter of seconds, which means time saved for other efforts and a more inclusive workplace. Similarly, with Google Cloud's Recommendations AI, merchandising and e-commerce teams can now drive 40% more customer conversions. That means a lot more happy customers and a happy sales team too. When you put together All of these productivity gains, powered by AI, across the organization, a 4-day work week is a very distinct possibility. Thank you so much.
Hi, I'm Irina Farouk, and my prediction is that by the end of 2025, 90% of data will be actionable in real time using ML. I'm sure many of you are pretty skeptical of this prediction, and that's understandable. A recent survey found that only 1/3 of all companies are able to realize tangible value from their data. And we continue to hear that many of you are trying to fix that by taking on the operational burden of managing data infrastructure, moving data around, and duplicating data to make it available to the right users in the right tools. So then, how do we begin to overcome these barriers before data can be actionable in real time using ML? Since our inception, Google has been focused on delivering highly personalized information that is highly trusted by billions of people around the world. Data is in our DNA. The same data infrastructure that's allowed us to innovate is available to you, and that is why we believe we can make this prediction a reality. Take, for example, our customer, Vodafone. As one of the world's largest telecommunication companies, Vodafone unified all their data so that thousands of their employees can innovate across 700 different use cases and 5,000 real-time data feeds. They now run AI development 80% faster, more cost-effective, all without compromising governance and reliability. So then, how can we help you achieve your own data infrastructure vision? The short answer is in 3 parts. First, you can't act on data unless you can see it and trust it. Today, we're announcing automatic cataloging of all your GCP data with business context in Dataplex. And you can integrate third-party sources too. What this means is that you no longer need to spend days looking for the right data, and instead can spend time working with it. But once you find your data, how do you know you can trust it? Have you ever been in a meeting where someone questions the validity of a single data point, and then nobody can trust anything that's being presented from that point onward? That's why I'm particularly excited about the new data quality and lineage capabilities in Dataplex, bringing intelligence and automation to help you trust your data. Second, you can't act on data unless you can work with it. To innovate, you've got to be able to use the best tools for the job across all your data. Speaking of the best tools, I'm excited about BigQuery's new support for unstructured data. Now you can be sure that your BigQuery skills will pay off across all your data, from structured to semi-structured to unstructured. It is also important to be able to use the best of open source tools. Last year, we introduced our serverless Spark offering. And today, we're announcing that you can run Spark directly from BigQuery with fully integrated experience and billing. But this is still just the beginning. We have a bold vision for our Spark offering to bring the Google infrastructure magic, all without forking open source. Take, for example, MindMeld, the shuffle service powering BigQuery and Dataflow that helps deliver scale, reliability, and performance that you know and love with those services. That's coming to a Spark job soon. Lastly, you can't act on today's data tomorrow. We've heard from many of you that you struggle with making real-time, in-context experiences a reality for your own customers. Dataflow, our streaming analytics service, powers critical Google services, and we believe it can do the same for you. With Dataflow, you can use Apache Beam to build unified batch and real-time pipelines. You can start small while having the assurance that you can process real-time events at extreme scale if your application needs it. To summarize, when you can see the data, trust the data, and work with data as it's collected, we can see how 90% of data will be actionable in real time using ML, and the incredible innovation that that will unleash. Thank you very much.
Hi, I'm Andy Goodmans, and I predict that by the end of 2025, the barriers between transactional and analytical workloads will disappear. Traditionally, data architectures have separated these mixed workloads, and for good reason. Fundamentally, their underlying databases are built differently. Transactional databases are optimized for fast reads and writes, while analytical databases are optimized for aggregating large data sets. Because these systems are largely decoupled, many of you are struggling to piece together different solutions to build intelligent data-driven apps. For instance, to provide personalized recommendations for e-commerce, apps need to support both transactional and analytical workloads on the same data set, and without negatively impacting performance. At Google Cloud, we're uniquely positioned to solve this problem because of how we've architected our data platform. Our transactional and analytical databases are built on a highly scalable, disaggregated compute and storage system and Google's high-performance global network, allowing us to provide tightly integrated data services. And to help you unify your data across your apps, today, I'm excited to tell you more about new capabilities we recently announced. First, Data Stream for BigQuery, which allows you to easily replicate data from transactional databases into BigQuery in real time. Next, Database Migration Service, which provides a one-click migration from Postgres into AlloyDB for operational analytics. And lastly, we support Query Federation with Spanner, Cloud SQL, and Bigtable right from the BigQuery console to analyze data in transactional databases. But don't take my word for it. Let's see how some of these technologies remove barriers for our fictitious company, Symbol Bank. Symbol wanted to integrate their core banking features in their app with market data to provide personalized, real-time investment dashboards. The problem was their app's backend was optimized for transactional workloads. So how do they maintain the responsiveness of their app while adding analytical goodness? Symbol Bank chose Google Cloud's new fully managed Postgres-compatible database, AlloyDB, offering the capability to analyze transactional data in real time. Now, migrating all their existing data with minimal downtime felt like a big lift for the Symbol engineers. But it turns out that Database Migration Service makes this simple. And I'll walk you through just how easy it is. Database Migration Service lets you migrate from Postgres to AlloyDB with continuous replication, minimizing downtime. Once we define where we're migrating from and what we're moving our data into, we can see the prerequisites for the migration directly in your UI. Sources are defined using profiles which contain host, username, and password, and you can predefine them like I've done here for Symbol's Postgres instance. Here we define our destination and some basic configuration options, and then we get to hit Create. This part will take a few minutes, so I've sped up time a little bit. Once it finishes, a quick test to ensure that it will all work, and then hit Create and Start. Once the initial dump is finished, we're now in a state where we have both the old and new database populated with our live data continuously replicating from old to new. And that means we can do cool stuff like testing the performance of our new investment features against both the existing production Postgres database and the new AlloyDB database side by side. Since AlloyDB is fully compatible with Postgres, you don't have to make any application changes. And as you can see, we're getting much better performance out of the new AlloyDB backend. AlloyDB is 4 times faster for transactional workloads and up to 100 times faster for analytical queries compared to standard Postgres, making it the perfect database for these kind of hybrid workloads. We all want to act on data in real time without the toil of infrastructure assembly and operations. We've given you a taste of how Google Cloud makes it easier for you to build data-driven apps on a unified platform. And this is why I predict that by the end of 2025, the barriers between transactional and analytical workloads will disappear. Thanks.
My name is Amin Vadat, and my prediction is, by the end of 2025, over half of cloud infrastructure decisions will be automated based on an organization's usage patterns to meet performance and reliability needs. At Google, we believe the work we do today with our partners will define the next generation of infrastructure for the world. While some people look at infrastructure as a commodity, we see it as a source of inspiration. This inspiration comes from delivering capabilities not available anywhere else and pulling in the future by operating at a level of reliability and scale that might otherwise seem unimaginable. Our infrastructure is designed with the scale-out capability needed to support billions of users who use services like Search, YouTube, Gmail, and our cloud services each and every day. We pioneered the model of entire buildings operating as a single computing and storage system. And with Spanner, we showed how services could run reliably at scale across the planet. And we've experienced network innovations like Google Global Cache, B4, and Jupyter, shortening distances across the planet. This gave us the opportunity to reimagine what was possible from infrastructure in terms of scale and capability. Look at the world around us. The time for disruptive innovation has never been more profound. We're seeing incredible demand on the industry's infrastructure, yet simultaneous plateaus in efficiency. You and your companies continue to push the boundaries of what infrastructure can provide. Yet the burden of picking the just right combination of components continues to fall on you. To address this, we've engineered golden paths from silicon to the console. These paths combine purpose-built infrastructure, prescriptive architectures, and an ecosystem to deliver workload-optimized, ultra-reliable infrastructure. So let's talk about the investments we're making in infrastructure at Google in power and performance to make all of this possible. We partnered with Intel to co-design and build custom silicon like this little thing. This is called an Infrastructure Processing Unit, or IPU, and it gives you massive performance and scalability to power high-performance, data-intensive apps. These IPUs are at the heart of our new C3 VMs. C3s include the latest generation Intel Sapphire Rapids processor and custom-designed offload based on the IPU that delivers 200 gigabit per second low-latency networking. And coupled with our new block storage hyperdisk, they can provide incredible storage performance. Now, let me show you something else. From the small to the big, meet the hardware behind the new Tensor Processing Unit, the TPU v4 platform. It's likely the world's fastest, largest, and most efficient machine learning supercomputer. This liquid-cooled board is a beast in both power and performance density. You see these pipes running across it, running chilled water over the board. They're there to ensure you extract the highest level of efficiency from this hardware. It allows secure, isolated access, and is at the cutting edge of services like natural language understanding, recommender systems, and image processing. The TPU makes large-scale training workloads up to 80% faster and up to 50% cheaper compared to alternatives. When you talk about nearly doubling performance for half the cost, you unlock your imagination in terms of what just might be possible. The same IPUs and TPUs that power your services are the foundation that will enable us to automate over half of cloud infrastructure decisions in the next couple of years. They will support the telemetry data and ML-based analytics to proactively recommend the best infrastructure. It will be based on an understanding of how infrastructure balance points correspond to performance and reliability for your individual workloads. We don't think that you should have to think about hardware specifications. That is last generation cloud thinking. You will specify a workload and will quickly recommend, configure, and place the best option for you based on your price, performance, and scale needs. We know that these automated, adaptive decisions deliver lower cost, more performance, and higher reliability than any handcrafted solution. So is my prediction that over half of cloud infrastructure decisions will be automated based on an organization's usage pattern correct? Honestly, I think it's going to be much higher than that. It has to be in order to keep up with all the advancements you're making in technology. The burden and complexity of infrastructure decision-making you have today will disappear through the power of AI and ML automation. And when you have freedom to focus on your solution delivery, the rate of innovation and customer benefits will only accelerate. While cloud has been transformative, we are still at the early stages. We're excited to continue to make the unimaginable possible and the possible easy. Thank you.
Hi, my name is Teran Giannini, and my prediction is that by the end of 2025, 3 out of 4 developers will lead with sustainability as their primary development principle. For the longest time, the focus was elsewhere. We needed to build it fast, build it securely, build it as simply as possible, build it at the lowest cost, build it reliably. Well, now it's also time to build it sustainably. We can't ignore the urgency required from all of us to meet climate targets. And while organizations are moving in the right direction, they struggle to take action. 65% of IT executives said they want to improve their sustainability efforts, but don't know how to do it. 36% of them said they didn't even have the measurement tools in place to track sustainability progress. So, how can we help them out? We can give them better data about the environmental footprint of their business. So today, I am excited to announce that Google Cloud Carbon Footprint, which helps you measure, report, and reduce your cloud carbon emissions, is now generally available. Let's take a look. Right from the Cloud Console, you can access the carbon footprint dashboard of your account. The underlying methodology is quite unique and is based on actual measurements of the energy used by machines in our data centers. It is also the complete picture of your emissions. Not only emissions coming from electricity production, but also on-site fossil fuel emissions and other embodied emissions coming from data center hardware. This is also known as scopes 1, 2, and 3. And of course, you can break down the data by Google Cloud Project, Google Cloud Region, and Google Cloud Product. With a simple click, you can export your cloud emissions data to BigQuery for further analysis and to provide your sustainability teams with the data they need to report on your company's emissions. We also want to help you build new applications that emit less carbon by making the right choice at the right time. Let's say you want to deploy a new application to the US West Coast. From a latency perspective, all of these options are very similar. Without more info, you might have picked Las Vegas, which happens to have a relatively carbon-intense electricity grid. But up in Oregon, you'd find a very clean grid, full of hydropower and therefore low carbon intensity. That is why it is indicated as a low-carbon region. In fact, a simple choice of Oregon over Las Vegas can reduce your gross electricity emissions of running that app by about 80%. And with this move, you not only saved carbon, you also saved money, since a compute engine VM is cheaper in Oregon. A move that can help you save money and carbon is easy to make. When we tested this feature, we noticed new users were 50% more likely to choose a low-carbon region when they saw the icon. And that can make a very big difference. So, how do we make it easy to identify more opportunities to lower your carbon emissions and deliver those options at scale? Well, Active Assist now shares recommendations to remove idle resources and their associated emissions. Actually, all of the sustainability features I just showed you today are embedded into Google Cloud Console and documentation. They are available out of the box at no charge and for all developers. Sustainability is too important to be complicated. Before I go, here are two things to remember. One, moving to Google Cloud gives you the efficiency gains and energy benefits to reduce your emissions. Two, when you build on the cloud, pick the region with the lowest carbon impact for your application. Because these tools are available, I believe that by 2025, 3 out of 4 developers will lead with sustainability as their primary development principle. Thank you.
Hey everybody, I don't know why I did jazz hands. Let's play with that weird energy though, together here today. Let's go. Good, so hi, my name's Richard Seroder. My prediction for you today is that by the end of 2025, over half of all organizations using public cloud will actually gonna freely switch their primary cloud as a result of all these new multi-cloud capabilities available. So quick story, I recently moved from the Seattle area to San Diego after a vacation this year with my family. We realized we needed something different. So bought a house in San Diego before I finally sold the house in Washington. And for a weird time there, I was multi-house, and that was not good. But it wasn't my desired end state, but that's okay. Sometimes you're in these multi-situations while you transfer from one state to another. And that's related to my prediction here. I think in the years ahead, we're gonna see companies use a multi-cloud strategy, not just as a way to hedge their bets, but as a way to actually switch from their first cloud to their next cloud. So research data shows that the majority of companies are actually multi-cloud today, meaning they use more than one hyperscale cloud. Sounds probably pretty familiar to most of you. I'm personally talking to more and more companies though, that are using multi-cloud technologies as a way not to shift just their workloads, but their mind share to a different cloud as well. So let's see what that journey might look like. What would that look like? Let's look at like 3 different steps. We'll do some live demos, what can go wrong. So first, that first part of the journey is how do we meet you where you are today with what you got? You probably use another cloud. That's totally cool, nobody's perfect. But here at Google Cloud, we've made some unique investments in a multi-cloud management plane that works with your compute and your data, even if it's on other clouds. So in this first step, you're starting to use Google Cloud, but you want to incorporate existing investments in other ones. So consistency matters a ton here, and Anthos plays a huge part. Let's see how. So first off, if you'll see here, I actually have an EKS cluster I built, and I've actually attached this to the Anthos control plane. From here, I can manage the cluster, I can view workloads, I can deploy things, I can troubleshoot, I can apply common policies. And even with our recent partnership and collaboration with the Crossplane project, I can actually create and manage GKE clusters, AKS clusters, EKS clusters, provision and manage them all the same way from Google Cloud, which is pretty cool. Now, what do you do with your data? We talked about compute. If I think about my data, how do I analyze all this? We know that data transfer costs are real. Consolidation isn't always the right option. And so for financial, strategic, or even policy reasons, your organization might need data in different clouds. It's okay. So with BigQuery Omni, I can actually have my data lake in Amazon S3 or here in my Azure storage account, and I don't have to move the data to actually run my queries against it in BigQuery. I can actually analyze it where it resides without moving the data. So this is one of many Google Cloud services that actually work wherever you are, whether they run across clouds or actually integrate with the different clouds. It's a big deal. So that's a starter phase, right? I'm building skills, I'm moving, kind of comfort in this new home I have, but I haven't moved really anything. So some of you might think this is where you stop, right? Multi-cloud is just use a bunch of clouds, but I don't think so. I think many are going a step further. So in the second stage, you start upgrading your tech where it is and growing your adoption of that secondary cloud. So step 2, as I start using Google Cloud services, let's say things like GKE, which are awesome, I want to use it even more and more. So I might introduce things like Anthos clusters to Azure and AWS. This is the GKE API and GKE software running across clouds, which is amazing. And just now, we just shipped the capability where I can even upgrade those clusters in place on another cloud from the Google Cloud Console. That's awesome. I don't have to jump all over the place to run all my infrastructure. Now here, you might also start creating a multi-cloud mesh and say, look, I want to actually maintain services that run across clusters in different clouds. In this particular mesh, my web app is spread across GKE, EKS clusters, all of these different places. I'm actually able to manage those services and see them and connect them wherever they are. Now let's talk about data. At this point in the game, you might use our great service data stream to redirect your existing Aurora cluster in AWS from Redshift. Maybe you want to steer it to BigQuery instead. And I actually built a stream that connects from my Aurora database and feeds the data in real time to BigQuery. Pretty awesome stuff. So use data stream to move data around as well. So that's cool. So for some, multi-cloud is a bit of a phase. It's not a permanent state. You're not trying to get there. Your final stage could be a full-on migration to your new primary cloud. So once you've invested in Google Cloud, you might start taking advantage of really awesome stuff like GKE Autopilot. This is a fully managed Kubernetes environment where we are running the whole thing. You don't manage clusters. You just deal with your workloads. It's awesome and exclusive to Google Cloud. Now, what's really cool is you may also continue to use Anthos on Google Cloud to manage all of your fleets of GKE clusters in all of our regions around the world. I'm showing you some new dashboards here that are coming out. And this actually lets me manage not just my GKE clusters, but I'm managing on-prem, bare metal, VMware, Edge, doesn't matter. I'm getting a view of my entire fleet and managing that. So now you get things like BigQuery for analytics, you're in Google Cloud, Spanner for distributed data, AI/ML for amazing insights, all these unique developer tools and more. So look, if you forget everything else that I've talked about here today, remember that Google Cloud has a really unique management plane that meets you where you are, but honestly takes you further. So this is why I believe over half of companies using public cloud today will freely switch their primary provider in the coming years as a result of all these great multi-cloud capabilities. Thanks a lot.
Hi, I'm Jana Mandic, and my prediction is that by the end of 2025, over half of all business applications will be built by users who do not identify as professional developers today. One of the most interesting opportunities as organizations evolve is that we will continue to see more development work in the enterprise taken up by teams and individuals outside of central IT. The adoption of no-code and low-code tools will unlock this potential by making the development process easier for more users. How many times have you been asked to do something, but you had to say no because your roadmap or feature request lists were already way too long? Well, with these tools, those business users you had to say no to can instead create apps and workflow automations themselves with no programming skills required. These no-code and low-code apps will be built collaboratively with developers like you who will provide the guardrails to keep the business secure while enabling business users to deliver their own solutions. And I'm not alone in thinking this prediction will come true. Leading tech analyst Gartner forecasts that by 2025, 70% of new applications developed by organizations will use low-code or no-code technologies. That's up from less than 25% in 2020. Organizations are getting ready for this change, and our customers are already moving in this direction. Globe Telecom, a major telco out of the Philippines, reduced targeted business process turnaround time by 80% through experiences built by their citizen developers. And now, it's demo time. Let me show you how Google Workspace's AppSheet is making all this possible today and in the future. Now I'm going to be Anne Gray, a business analyst, trying to help my team save time managing request approvals. Currently, the process is manual and disorganized, spread across ad hoc emails and chat messages. So to fix that, first I'm going to build a no-code request approval app, and then I'll show you how my team and I can use this app to efficiently manage our development workflow, our approval workflow. With AppSheet, I have a single place to store my data and build my apps. I can also connect to other easy-to-use data sources like Sheets, or with the help of IT, I could connect to CloudDBs. Let me show you the solution that I could build as a business user. Here's my database. AppSheet helps me structure my data and prep it for app building. When I'm ready, I can create a new application with a single click. This creates a prototype app that will be usable on any desktop or mobile device. After some customization, here's what I've built. I have a new request view for users to make requests, and an approval view for approvers to do their thing. Each of these views is available to me in mobile apps and desktop apps by default, and I can also configure them to show up in Gmail and chat, meeting my users where they are. Here is my Google Chat app. With this, my users can make requests directly from their team chat space, and it's reusing the same request view I configured earlier. Here's my automation that will send the approval view to the approvers in email. When I'm happy with my app, I can share it with my users, and I can add it to my chat spaces. Throughout this whole process, everything I created is controlled by governing policies set by the company's workspace admin. For example, here's what happens if I try to share the app outside of my domain. AppSheet blocks me and keeps company data secure. This allows IT to do two things. One, keep a clear line of sight on all apps so they can deprecate, update, and retire them when necessary. And two, restrict access to only those users who need it. Now let me show you how my colleague Jeffrey and I can use this app to manage our request and approval workflow. I'll be Jeffrey now. I'm on Anne's team, and I have a request to make. Let me ask Anne how to use her new app. She's added the bot to the space, and now I can quickly submit my reimbursement request. Okay, now I'll be Anne again. I got this email for Jeffrey's request. I can review and approve it directly from here. And if I have a pile of requests to review, I don't have to click through individual emails. I can pop into the app and see everything in one place. This app is accessible to all the users, requesters, and approvers. With simple sheets-like expressions, it's configured so the requesters see only their own requests, and approvers see all the information that they need. You saw just how easy we are making it for non-technical users to create business applications that meet their immediate needs. With no-code and low-code, you and your business users now have more tools to work with. This is why I believe that over half of all business apps will be built by users who don't identify as professional developers today. Thank you.
Well, folks, that's a wrap on our predictions. We're excited about the conversations this will start and continue with all of you. Remember, if you want to share your own prediction, use the hashtag Google Cloud Predictions to tell us all about it. We can't wait to hear from you. Thank you for your continued inspiration and for partnering with us to build what's next. So, are you ready? Enjoy the rest of the show. Thank you, everyone.
Hi, I'm Shaquille O'Neal, and I'm the founder of Big Chicken. So you gotta do that at the end when you say Big Chicken.
Big Chicken is Shaquille O'Neal's emerging fast casual restaurant chain that focuses on big fun, big flavor, and big food. When you're trying to build a national chain, communication is so critical. To do that, you need a great partner. We're really lucky that partner is Google Workspace.
You know, Josh, every time he does a presentation, he just loves Google Slides.
As the person responsible for our marketing, probably the best at Google Slides.
His presentations is like I'm at a movie sometime. I'm just sitting there going.
I've got some great new chicken sandwiches for you to try. Brand new recipes. Isn't there something important we're supposed to be talking about? Good recipe development comes with collaboration. Using docs in Google Workspace gives us the tools we need to collaborate together.
Shaquille's life gets crazy busy, as does our entire board.
When you want to talk to me, make sure you put on my Google Calendar. Google Calendar is my girlfriend. I don't know anything I'm doing unless I talk to my woman. Google Workspace, productivity and collaboration tools for all the ways you work.
Google products provide the information you need when you need it. But But why can't you get the same kind of answers for your business? Looker, Google Cloud's business intelligence solution, is here to solve that problem, enabling you to go beyond traditional dashboards and make your organization's information accessible and useful. Bringing this innovation to business will be revolutionary, just like navigating a city after Google Maps. Looker is Google for your business data. Here's what we mean. What if Google AI were built into the tools you use to store and analyze data at work? Google's Vertex Ai Vision takes data like video, images, and audio, and in real time, turns it into structured data, ready for business intelligence. Going beyond the dashboard means using Google Glass Enterprise to see insights and recommendations based on your data in real time. More access, more transparency. Now that's Google for your business. With Google Maps, you know if a restaurant is busy before you go, or you can get rerouted around a traffic jam. Looker will help you connect similar dots in a predictive way.
A concert in 5 days will increase foot traffic by 65%. Would you like to adjust staffing and inventory?
Yes. Looker and AI lets you respond to changes in demand and turn insights into action.
Foot traffic continues to be busy. Encourage customers to visit an alternate shop with a reward card?
Yes. Smarter insights mean better experiences and happy customers. So go beyond the dashboard and transform the way you do business with Looker, powered by Google Cloud.
We started with the exponential roadmaps goal, 0 carbon emissions by 2050.
Where our emissions primarily stem from: device, CDN, networking, and cloud.
Our goal is actually to get to 0 emissions by 2030.
Backstage was built internally at Spotify, so it unifies your tooling, your services, docs, and apps under a unified, consistent UI. We donated it to the Cloud Native Computing Foundation.
Amazing to see how many people at Spotify actually care deeply about this topic.
Cloud Carbon Footprint is actually an open source tool developed by ThoughtWorks.
The only thing that's limiting us right now is just people hearing about it.
It leverages cloud APIs to provide visualizations of estimated carbon emissions.
We leverage Bigtable, GKE. It starts not just from the cloud, but it goes all the way out to our end user devices.
We want to empower not just Spotify internally, but the broader developer community to reduce their carbon footprint.
Ready to race.
Let's serve up another round of high-speed drama.
Hello again, Munich developers, and all of those Europe, Middle East, and Africa-wide developers following us online. Hope you are all well-fed now and ready for more content. So we've got a great session coming your way now. In fact, I had the honor to meet our next speaker at an event in Frankfurt, Germany earlier this year, and I was personally very inspired by her story, and I think many of you will be too. So, up next, I'd like to welcome Chanel Greco, a developer advocate for Google Workspace.
Hey there. So, my name is Chanel, and today I'm going to tell you a personal story. So it's my story as a woman in tech, the ups and the downs, but more importantly, what I've learned from it, and hopefully also inspiration for you. A while ago, I read a very interesting book. It's called Atomic Habits by James Clear. Maybe some of you have read it too. And it speaks about atoms. So atoms are the smallest particle of an element, of a chemical element. I know that so exactly because I Googled it. And it speaks in the book about how tiny little tweaks to habits you already have, or maybe even stacking new habits upon each other, so doing little improvements, can have a compounding effect and lead to real change in whatever we're trying to improve. So I want to have you keep that concept of atomic habits in the back of your mind as I tell you what I experienced. Now, let's start off by looking at my first learning, and it has to do with a decision I had to make, and admittedly, well, I made the wrong decision. But let me tell you why I made that wrong decision. Well, you see, at a very young age, it was about 8 or 9, something like that, I fell in love. I would call this, it was love at first click, because I started playing computer games. And I was fascinated by this. As a matter of fact, today, a bit more than 30 years later, I still consider myself a gamer. One of my favorite ways of unwinding is switching on my console. And this love of computer games, after a while, it triggered real interest in technology. And I could imagine working in information technology. At a very young age, I had to decide, okay, so what am I going to do? What am I going to be? What am I going to make out of my life? And when I mean young age, I mean really young. I was 14. So you see, in the country where I grew up, traditionally, especially when I was a teenager, 2/3 of high school students would then go on and do an apprenticeship. So that means 2 days a week, usually you go to business school, and then the rest you work on site with your team at the company that hires you. So I knew I wanted to do that and not go to university, simply because I wanted to earn money. So I knew I wanted to do an apprenticeship, so that meant at 14 I had to start applying to these companies. So the question was, well, what exactly are you going to apply for? What for a job are you going to apply for? Now, deep inside myself, I knew I wanted to work in information technology. But there was a big, big problem. Because for me, this is what working in an information technology business meant. Working with much older men and being the only girl in business school. Now, you have to keep in mind, I was 14. Now, I don't know about you, but when I was a teenager, it was all about fitting in and not being the odd one out. You wanted to be with the cool kids, you wanted to be with everyone else, and not be the weirdo in the class. So for me, that fear of being the only girl or working on a team with much older men was real. After all, I know no women who worked in technology. I literally only knew men. Now, as I was preparing this talk, I asked myself, well, wait a minute. After all, you were 14. You lived in a town outside of the big city. What if your assessment of the situation of that there was no women in technology was wrong? What if you were the problem? So I did a little bit of research, and I found the statistics for the for the country where I grew up in. But before I show you that, I want to do a little quiz. Because have you noticed, I kept on saying the country where I grew up in, but I didn't tell you which country it is. Now, obviously, for those of you who might know me here, you don't get to guess. But for all the others who don't know it, I'm gonna give you 3 hints, and let's see if you get it right. And maybe Emily has some swag for you, because I don't. So, first of all, first hint is, it's a European country. Second, and this is gonna make it a bit more interesting, we have the highest consume per person when it comes to chocolate worldwide. Yeah, Switzerland, exactly. The third hint would have been, obviously, cheese. Melted cheese on top of potatoes, or dipping bread in melted cheese, but anyway. So you're all web-fed, so you don't need any fondue. So exactly, these are the statistics for Switzerland. And we have on the left side for apprenticeship, so this is typically a 4-year apprenticeship that you enroll in, and then on the right side we have university. The year is 1999. Why? Well, because that's the year I, back then at 15, enrolled in my studies. So we see 7.3% of the students that enrolled in apprenticeship were female, and 10.9% in university who started studying information technology. So when I saw this statistic, I thought to myself, well, 14-year-old you was probably spot on with your assessment of the situation, because I most likely would have been the only girl in school, and probably, or definitely, would have been the only young girl in a team with much older men. But surely, 2022, things are much better. Well, nah, not really. Things have improved, but we're not there yet. So we have for 2019 on the left side, and for 2020, the newest statistics. So improvement there, but we haven't quite reached where we want to be. Now, what did I learn from this? I strive to be a role model for young girls and women and get them excited about technology, because I, as a young girl, lacked that moment of seeing, oh, if she can do it, then I can do it. Now, this talk is from my perspective, a woman in technology. But if you are part of a minority group that is underrepresented in technology, well, the same is true for you. You can be a role model for the people from your minority group, that they can look at you and say, well, if that person can do it, then I can do it too. Now, on to my second learning. After a couple of years, and by the way, I didn't tell you what I ended up enrolling in as studies. So I did an office clerk apprenticeship, and typically girls then go on to do stuff like PR, HR, marketing, so kind of like the typical women's job. I ended up in bookkeeping, my worst job ever. So after a while, I was able to ditch that, and I got the opportunity to start working as a hardware supporter. And obviously, I worked in a team that was, well, almost exclusively male. But I was really intent on, giving my best and learning as fast as I could. And part of me learning a new skill has always been buying books. So I had a nice big book about computers sitting on my desk. And I remember one of the technicians came over to me to talk about some customer support case, and he picked up the book on my desk, and he looked at it, and he started laughing. He was like, what? You still have to read books about computers? And I remember how hurt I felt, because here I was giving my all, and he thought it was okay to make fun of me that I didn't have the experience that he had. Now, a couple of years later, I started working for another company, and I was lucky enough to have managers who believed in my potential, and they gave me projects to manage. So I was an IT project manager. And I remember one day, one of my colleagues who worked on a team with me said, do you know, Chanel, what the engineers say about you from the engineering team? Well, obviously not. They don't tell me. So he said, well, they say Chanel is cute, but her technical skills aren't the best. And if I or when I think of that statement, I must say, with the second part, they were spot on again, because here I was. In contrast to them, I hadn't studied computer science or information technology like they did. I was someone learning on the job, doing courses in the evening. So they had studied. They were usually 10 to 20 years older than me, so they had much more on the job experience. So yes, their assessment of my technical skills, I wasn't at the level that they were. But here's the thing. I cannot imagine them saying, well, Luke is cute, or Luke is athletically built, but his technical skills aren't the best. So it's okay to say something like that about a woman. And that's what bothers me about that statement. Now, what did I learn from these two situations? Whenever possible, I personally prefer working in diverse teams, because later on in my career, when I did also work as a developer, I worked in diverse teams. And obviously, diversity is more than just gender. It's people from, that are very different from each other. And in those teams, I felt safest, and I also performed the best, because I think when you feel safe, that's when you can excel. Now, I believe there's also another reason why we need diversity. Now, as software developers, we're creating solutions for problems that a very diverse set of people, of users, need and will be using. So wouldn't it make sense that the teams working on these solutions are also diverse as possible? And I can imagine that most of you here, if you're in a position to hire, that you definitely also want to hire for diversity. Now, on to the third learning that I had, and it has to do with something that I personally think is my superpower, in the sense of that, for me, it unlocked many doors. And it's also the reason why I'm here today, why I'm able to do my job as a developer advocate for Google Workspace. And it has to do with that in May 2015, even though I have been in IT for a long time, I finally decided I really want to learn how to code. I set my mind on that. Maybe you could say I was a little bit naive, because I had no idea how difficult it was going to be. So I signed up for Rails Girls Zurich. And Rails Girls is an initiative originally from Finland, where during a weekend, for example, a lot of women come together and learn how to code. As a matter of fact, I remember there weren't only people living in Switzerland there. Even from the south of Germany, a lot of women traveled to Zurich to be able to be part of that boot camp. And the way it works is that you have these smaller groups, so you break up the participants into smaller groups, and each group has a coach that teaches you the fundamental of Ruby and Ruby on Rails, the framework. Now, by the way, these weren't only female coaches. There were actually more male coaches than female ones there. So for me, this changed everything, this coding boot camp. And when I think back to that weekend, there's certain things that I vividly remember. One thing, I was totally overwhelmed. I wasn't understanding half of what they were telling us, but we were in an environment, there was this atmosphere around us where it was okay for us to say, I'm sorry, I didn't get that. Could you explain it maybe a little bit differently? So we felt safe to be ourselves and to learn together, and to, also be okay to say, I'm sorry, I didn't get that. And on the other hand, with these people who were coaches, I, after a couple of months already, started coaching too at events and at boot camps. And some of these coaches who really encouraged me to get into technology did actually become my colleagues, because I did stick to coding and I became a full stack developer for Ruby on Rails. So you could really say this fundamentally changed my life. Now, what is my learning from this that I experienced? Well, whenever possible, I like to be a mentor or a coach at coding events for girls or for women. And for a while, I worked as a coding teacher, and there was a special IT week where schools in Zurich sent classes to learn about information technology. And I had one class, girls around, what were they, maybe 9 or 10 years old, and I showed them how to write HTML and CSS. And that is incredibly rewarding to see these girls having fun with technology. And hopefully that also in the future, they remember how that was and also decide to get into information technology. Now, I personally invite you, if you are a developer or if you have coding skills, to have a look at this opportunity, to also become a coach and mentor. And to make this a little bit more tangible for you, here are a couple of the initiatives that you can maybe have a look at and maybe even sign up to as a coach or mentor. Now, I specifically also want to mention the Women Tech Maker initiative by Google, because this is a global initiative. So you will find chapters in Berlin, Zurich, Nairobi, Lagos, Paris, London, and so on. So I definitely invite you to have a look at that. Now, I would love to connect with you. As a matter of fact, here are my social media profiles. You can scan them. Because I would really like to know how you see this situation, maybe what your experience was, and if you agree with what I said, or maybe you even have cool ideas that I haven't thought of. Now, let's come full circle to what I told you in the beginning, to keep that about atomic habits in mind. If you think about it, you and I, we're atoms. We're the smallest elements or particles of our families, of our teams, of the communities we're part of. Now, if we make maybe little changes, maybe one change that I mentioned here, that can have a compounding effect. And we can drive diversity in tech from bottom up. Thank you very much.
Hey developers, welcome back. And now we're heading into a super key topic area, regardless of your company or your tech focus, security. So please welcome our next speaker, who is a hybrid multi-cloud fellow. He's going to talk about how to check your security posture. So welcome Jason Quek, the global CTO of Devo Team, Google Cloud.
Hi everyone, thanks for joining my session today. Today I'm going to talk about a very important topic, about checking your security posture in Google Cloud. So first of all, I'd like to give a bit of background. Where did we come from and why I'm on this stage talking about this? So when we first moved to Google Cloud, we decided that we were going pure cloud native. The number one priority for us was developer agility. So how do we get the productivity to build products and applications on the cloud as fast as you can and as cleanly as you can. And we also had to combat the changing cloud landscape with continuous new features and releases like you see in the Cloud Next all the time. So understanding what to use and what not to use in our cloud landscape. So Devo Team G Cloud is a Google Cloud Managed Services partner with a global presence, which means that we are present in 18 countries. So which means also different kind of regulations and different kind of rules they have to apply for all customers that sit across the globe. And it's not an easy thing to do. We also have to pass different things like the audit. So to become a managed services partner in Google Cloud, you actually get audited by Google itself, and that's kind of stressful at times. So in one section, it's about security. How do you maintain a good security posture so that you can give peace of mind to your customers? We also have many specializations, and in which of them, they go through our security posture and validate that we are secure and we are poised for success. So it can feel hard to create a secure cloud environment because there's so many rules, there's so many features, things like organization policies, things like security command center, things like IAM rules. So it can feel hard at times to what do you enable and what do you disable in your cloud environment. So a bit of context as well. In 2018, we started on Google Cloud with what I call the cloud foundations. So building the typical landing zone with the different kind of governance in place. Next, we moved to GKE and utilized that to great effect. We got into GitOps and we started with Anthos. And 2020, that's where we achieved managed services provider status so that we can give that kind of extra service to our customers. And next, we built things like accelerators in different workloads. Now, so back in 2018, so to bring you back a couple of years ago, like 4 years back, there was a few different requirements we had to look at our landing zone, right? First, we had to work on different customers, proof of concepts. So you're building different POCs, you're building different kind of customer environments. So you had to build a multi-tenant strategy. Secondly, we wanted to test out new features on Google Cloud to be ahead of the curve, to understand what is going to be the next trend in the market and what should we get ahead of to learn. And next, we want to do it as automated as possible. Because as you all know, there's a big lack of talent in the Google Cloud market. We need much more developers, much more cloud architects in the market to get Google Cloud really running as smooth as possible. So as a byproduct, automation is key. Next, we want to make it intuitive and easy to navigate. For example, if we want to onboard a new engineer, they should be able to look at the cloud landscape and understand where to go, how to navigate, and how to build things. So it should be as close to best practices as possible so that we do not have to reinvent the wheel. And last thing, finally, is to be secure because we cannot lose information and data, right? So with that, we looked around the 6 main topics. So we things like governance, networking, logging, monitoring, security, building, because for example, building actually is a key part of security as well, how to prevent build shock. We had to make it multi-tenant with different customers sitting in different environments, as well as our own sandbox environments for our developers. And also we run internal applications for customers as well. So you can imagine it's a very large multi-tenant environment with different regulations, different kind of rules for different countries. So it's quite a sprawling landscape. So we sit almost across 3 organizations, if you know the organization node in Google Cloud. thousands of projects, hundreds of folders. So in 2020, we took a step back because that was where really the cloud really boomed. And we said that, okay, we need to identify which technologies were really key to get on board so that we can leverage and accelerate. So first of all, we say that, okay, we're going to go with Terraform, right? We're not going to go with Cloud Deployment Manager. So to kind of adopt an open way of working. I see some laughs in the audience. We looked at things like Cloud Build, Argo CD, which we found that really fitted the way we work, that creative way of working. And we came across also this idea of the Google Cloud Foundations, right? And what is Google Cloud Foundations? This is where we realized that we had to use this great tool that was produced as open source. It's called the Cloud Foundation Toolkit Scorecard. So remember the scenario we came from. We had a large, sprawling cloud landscape with multiple projects that meet multiple use cases, POCs, sandboxes, production environments, staging environments, that you have teams in different countries building all the time and delivering all the time for over 2,000 customers. How do we score ourselves on security? So this is where this came in. I can recommend you can do that. So what you do is that you can write what I call policies. So this is a very typical policy they can download from the source repos. So it's a very simple one. It's just basically anybody that's not Delta.com should never be an owner in your project. Very simple rule, right? So with this kind of policies, I would like to do a walkthrough. So the first step, there's 3 easy steps to do this, to check your cloud security posture today. So 3 easy steps to get rated. Number 1, export your asset inventory. So understanding what sits in your cloud, right? Just simply run these Gke commands. It's easy peasy. You get a list of all your service accounts, firewall rules, applications. Everything comes out in a huge JSON file. It covers things like IAM rules as well as resources. Next, you get your policy library from Gke Security. I'm not sure if anyone has implemented Gke before. You can raise your hand. Yeah, Gke, great, awesome. Yeah, I really recommend it as well. It's a continuously checking your security posture. So there's a great base policy library here. So it gives you like the basic defaults, things like that, the owner rules, right? Clone it, and then just run this command, CFT scorecard, and you point to a policy path, and you point to where your bucket sits, where you have your asset inventory. With that, you get a list of violations, and the violations as well will link to the different kind of rules that you have implemented in your policy library. So how do we tackle all these different rules as well? Like, what do we start with first? So first, we tackle the IAM violations, because first we want to make sure that no one's accessing the system that shouldn't be accessing the system, right? So throughout the experience with customers and with other people as well, like a simple thing like restricting the age of how long your service account key can live for. So for example, how many of you have service account keys that have been floating around? For example, if you have a new joiner or a person that left the company and they bring along the service account key with them. So actually, if you do not have a rotation policy today, this thing will just pop up as a violation. So you have a service account keys that has lived for longer than, for example, 100 days. This also then gives you an insight about what you have to fix and what policy you have to implement. So this could be maybe a missing process in your company onboarding phase. So maybe developers should download a new key every 2 days, for example, from a bucket. So make sure that those keys will never be misused. Just let it die. And so this was a typical constraint that we found out, okay, we have some service account keys that have been living for too long. We have to deprecate them and rotate them. And also fix our processes, right? Next, we had to rethink the project creation process. So a lot of the kind of flaws or issues that we found in violations was actually due to this, how you create a project, right? That's actually a very simple thing to do. You go to Cloud Console, you click Create Project, and you're done, right? Like for example, do you know that when you create a new project, in the quotas page, BigQuery analysis is unlimited, for example. So any developer can create a project and can consume 20,000 worth of BigQuery analysis cost within 1 day, if they're not careful. So how do you do that in a way that you can actually make sure that you are as secure as possible. So we had to fix issues at the root. So we started writing additional constraints. So one of them, for example, is identifying cost owners and countries of where they sit. So making sure that each project has its owner. And also have a PR request rule, so that when you try to create projects, it must be validated by the CTO of the country. So when we scanned our cloud landscape as well, we found that there were many ways of labeling. There was not, it's always hard to follow rules on Confluence, for example. When you create a documentation, you say that everyone should do this same way. Most of the time, it gets out of skew. So you need to still monitor it and see which of these things that you have documented down, whether the processes are followed. So trust, but always verify. So this is a way of verifying it. Next, we also had to think about reworking our modules. So remember, we chose Terraform, right? And we started to build with Terraform, and we started to use our modules, and we use a lot of open source Terraform modules. So we just get it off from GitHub, from Cloud Foundation, and we start to use them when we want to go fast, right? That's why you leverage open source. But we realized that you cannot assume that open source actually automatically meets all your needs of each customer. And this is the reason why we had to create our own Terraform modules. They were specific to GKE, PubSub, ASM, for example, Enterprise Service Mesh. And I'll give you an example why. So if you go to the next slide, like for example, in this is a copy-paste from a public GitHub repo for ASM. So in here, when you create an Enterprise Service Mesh on a GKE cluster, you enable the GKE hub feature in the same code, in the same module, right? Which means if you create 5 Enterprise Service Meshes across 5 clusters, and if you destroy one of them, it will disable the feature for the entire project. So this is the kind of things that you have to actually investigate when you look at open source as well, to see that even though it is something published open source, is public, is well tested, you have to see, does it fit your need? And can you understand what goes on underneath as well? And this is what we realized doing our security posture check. So that's what I found out. So you only will discover this when you try to destroy the ASM. You realize that, oh, suddenly the feature is disabled. And lastly, we start to think about even extend it further and do definition of additional rules. So for example, we have many customers within FSI, healthcare, manufacturing, and all of them have different kind of data locality requirements, for example. So creating location violations, so understanding that some of the data sets can only sit in certain location, gives you a way to verify that your data should only be in a different area. And you can do the same thing for your GKE clusters, for your cloud storage buckets, and so on and so forth. So you can basically, if a developer does something wrong, they will be notified when you do the next scan, right? And this really make it very easy to adopt a policy as code approach, which you find works better than merely maintaining a bunch of rules as documentation. So some of the learnings that we had. So there's a quote by Larry Page, always work hard on something uncomfortably exciting. So why do I call it uncomfortably exciting with security? Because honestly, who wants to look at your own security rules at times? Because you're worried, okay, I made something wrong, I did something wrong, I might be the reason for this security breach. So it's very important to open up those problems that surface up to yourself, rather than letting some attacker or some outside adversary discover it on your own. So it's uncomfortable, but do it. Do check your security posture. So, and also with open source systems. So when we look at our security posture as well, we found out that a lot of CVEs are being updated all the time, how to deploy it. And as well as when we recommend an open source system to work on, we always have to understand, can we support this open source system ourselves? In the event that somebody stops supporting it, starts doing PRs, starts fixing bugs, can we go ahead and fix those bugs ourselves? And this is a great thing. We love open source, and we love to use it. But the thing is that if it goes away from this open source system, we'll be stuck on it, and it will take a few months to migrate from it. So anything we pick and choose, we must go through a checklist, and we see, are we able to understand how can we support it? Can we explain how it works? So understanding and explaining how it works is very important as well. And can we extend it? So that can we add on to it? Is it something that's protected and you can rebuild it? So next, what's next in our list of activities? So in 2023, we're going to start looking at things like Kubernetes config connector and OPA, Open Policy Agent. So like you see the constraints they've just defined on the screen. So Google has come up with a new way of working. Instead of using Terraform, you create Google Cloud Infrastructure as YAML files, right? And you deploy into KCC, which is then instantiate those resources on your cloud landscape. And then you use things like Open Policy Agent to block any misconfigured infrastructure. And that could be a possibility. So it's always important to update on the latest tech and see does it fit for us. But we cannot only protect from attack at the source, we also have to do audits, which is why something like the Cloud Foundation Toolkit is always good to have, because you can audit at the end of the year to make sure that you're in compliance. And also things like the Security Command Center. So there's another new feature that Google came out with, I think last year, that has a lot of these constraints they have defined for you with machine learning and also with the different benchmarks that you can easily purchase and deploy. But right now, we have our own policy library that we maintain and that we use to regulate our infrastructure. But it could be a good idea to go to those two in the end. So yeah, so it looks very similar. You're creating YAML files for, like, for example, constraint templates for PubSub. So ensuring that you have the labels, yes, always labeled. And it's basically a gatekeeper, so ensuring that nothing gets sent in that's wrong. And with Security Command Center, you take things the next step. So always doing an asset inventory export. So the whole security posture is always around your assets. Taking the export, trying to figure out has it been any misconfigurations, and also do threat detection. So that's something that's also extra that we're looking at. And also what's nice is that it has the best practices there as well, like CIS, NST, which we have built in our policy libraries, but it's nice to have somebody updating it for us. Like moving to a managed service is always something that we choose to do. Also with that, I end my session. My email is actually hidden by the round thing. But if you want to drop me a mail to talk about security or ask about our policy library, we're always happy to share. So it's jason.quack@devoteam.com. So feel free to drop me a message anytime. Yeah, I'd love to connect on LinkedIn as well. Thanks.
Welcome back, everybody, and continuing on the critical topic of security for developers. Our next talk is how to secure your software supply chain, and you're going to hear this from a strategic cloud engineer who comes from the beautiful German side of Lake Constance. Please welcome Christoph Grotz.
So, good afternoon. My name is Christoph Grotz. Emily already announced me. And today I would like to speak to you about how you can secure your software supply chain and what's the things you might want to look out for. So, before we dive into the details, I'd like to give you a quick overview of software supply chain security and why it's such an important topic these days. Your applications normally consist of source code that your organizations create and dependencies that you consume from third parties. You probably have a build process that takes the source codes and those dependencies and creates packaged software out of that. These packages, you either run them in your organization or maybe other parties consume these packages as dependencies from you. The dependencies that you are consuming are provided to you that might be open source packages or that might be commercial products from other contributors. So these contributors, they have their own software development lifecycle with their own security processes in mind. This, as you can see, constitutes a software supply chain, where you can be a consumer of dependencies, where you can be a provider of dependencies, or often you're actually both. This may leave you vulnerable. We are consuming software from a wide range of sources with unknown contributors, and we don't really have the transparency into their processes. We are seeing a surge in attacks on this software supply chain. Sonatype has noted a 650% surge in supply chain attacks year on year. And Gartner is estimating that by 2025, almost half of the world's software organization will have experienced software supply chain attacks. At Google Cloud, we are observing real-world attacks on a wide range of vectors in the software development lifecycle. Most organizations are focusing on source code scanning and vulnerability scanning of the source code. But with the vectors we observe, like compromised build system, compromised package repositories, injection of compromised packages, those methods are not really up to the task. So the question is, what can you do to improve your security posture? As you have already heard in the keynote, we're happy to announce Software Delivery Shield as Google's answer to that problem. Software Delivery Shield is a holistic solution. It really tries to help you from the development all the way into the runtime. It's built on Google internal best practices like trust-based policy systems. And Software Delivery Shield is a modular approach. You can take all of the components together, or you can take individual components and integrate them with tools you are already running as part of your software processes. Software Delivery Shield supports your security advices directly in your IDE and workstations. It helps you by managing the security posture of your dependencies. It provides out-of-the-box security capabilities to your build pipelines. And it helps you with security posture management on your runtimes like Gke and Cloudrun. And with trust-based policy system, you're able to connect all of those individual parts together. So let's start with cloud workstations. A secure software development lifecycle starts with where the developers actually develop the code. Cloud Workstation provides fully managed development environments in the cloud, supporting popular IDEs like VS Code and IntelliJ, and Java JetBrains IDEs. It's designed with security in mind, with a number of features around that. Administrators can configure private ingress and private egress. They can configure VPC service controls to prevent data exfiltrations. And forced image updates of the workstations make sure that the developers are always working on the latest version of the development environments. With Source Protect, we shift dependency vulnerability and license awareness left directly into the IDE of the developer. This gives the developer much faster feedback, increasing productivity when it comes to closing security gaps. This obviously also works with cloud workstations. We improved artifact registry with a long list of features focused around security. The goal is to provide insights faster, simplify dependency governance, and reducing attack vectors. Cloud Build now supports out-of-the-box Salsa level 3 builds. This means in addition to already providing ephemeral and isolated build environments, Cloud Build now also provides authenticated and non-falsifiable build provenance. That's very important if you need to have auditability on your builds. And, sorry, one step back. In the new Security Insights panel, I think you all seen that in the morning already in the keynote. You get now the Salsa level of your build, you get the software bomb of your build, you get vulnerability information, and you can see the build provenance information. We're going to take another look at that in the demo. On the runtime side, we get additional insights in Gke and Cloudrun. So in Gke, we now have a new feature called Security Posture Management, which continuously scans your Gke environment and gives you recommendations on how you can configure your workloads with PodSec security best practices and where you have vulnerable images and workloads running in your environment. And on Cloudrun, we also have the Security Insights panel that you already know from Cloud Build in place so that you can see the security posture of the container you're running. To tie everything together, binary authorization allows us to make our security policies actionable. So we can verify with binary authorization that each step of our security process was executed, that we have the attestations, that this image, we can trust it, we can run it on our runtimes, so Gke and Cloudrun. So next thing is we're going to take a look at how this all actually connects into the system. We're going to start with seeing how Software Delivery Shield helps us to create secure containers. We start with Cloud Workstations. We're going to see the features there. We're going to see the insights that it gives us. Then we're going to take a look at how Cloud Build helps us to build the container. We're going to take a look at container analysis for our container vulnerabilities. Then we're switching over to the runtime. We're going to check how binary authorization gives us assurance that only trusted containers are actually running in the runtimes. And we're going to take a look at security posture management and how the insights that we get from there actually then feed back right into the developer's environment to fix the problems. So, Then let's move over to the demo. And of course, I need to log in. You know, security starts on the developer machine. So that's the Cloud Workstations overview panel. You can see I already have a workstation. We're going to take a look into that in a second. In Cloud Workstation, when you want to create, as an IT administrator, create a new configuration, so developer workstations are spawned from configurations. We get a wide range of features that we configure. On the one hand side, we can make decisions on a cost basis. They're not now really security relevant, about how many workstations we want to have pre-configured already running to increase developer productivity. But we can also define things like machine types. So how big should our developer machines be? Do we need GPUs in case that we're doing AI work on those machines? We can configure shielded VMs, secure boot, and so on, what you already know from other parts of GCP. And we can define the actual developer environment, so we can select which image we want to run, so a container image we want to run as a developer workstation. Here you can see that's a bigger list. So we have Code OSS, we have support for different JetBrains IDEs, or you can also configure a custom image if you want to pre-configure the developer environment with the tools that your organization needs. And we can, of course, also configure storage for those machines. Now, let's jump directly into the workstation. My workstation is already running. I can go here, and I need to reload the window. Give it a second. You can see it's rather fast. So in my Cloud Workstation that I have here, let's get rid of that. I have Java available. I should have Maven available. Yes, wonderful. and I'm working in a very standard Spring Boot project, slightly older version of Spring Boot. I'm using a new feature from Artifact Registry here, that's remote repositories. So in Artifact Registry, as you have read on one of the slides before, we now support virtual and remote repos. So here I have a cached remote repository with Maven Central, so that when you now do a Maven clean install, the dependencies are downloaded much faster. Then some version configurations and dependencies, but oh no, what's that? You can, see we have a few linter errors here, this red curly lines. Let's hover over that, and that's now source protect. So here you can see that we have security vulnerabilities direct on this dependency. Let's check the list out. There's a remote code execution in the Spring Framework version 5.3.16. But hey, my dependency is actually Spring Boot Starters Web. It gives us also dependency insight, this vulnerability insights on transitive dependencies. And I mean, I guess you all have at least once in your life called Maven install, and then it starts downloading half the internet, and maybe you're sitting there and wondering, what am I actually downloading right now? So it's really important to understand you might have just one dependency in Maven, and that one might not have security vulnerabilities, but who knows what you're downloading, and with those transitive dependencies, you can be vulnerable. And what you can also see here, that's what's quite nice, for each of these dependencies, if there is already a version that doesn't have this vulnerability anymore, where it's fixed, it gives us also the hint, okay, if you update to this minor version, for example, this CVE is gone. So my product owner wanted me to do a fix, so I'm just going to ignore that real quick, and he really wanted me to push that into production as fast as possible. So let's just make our small fix, commit the controller, and push it into our Git repo. So cloud build, in a second, hopefully, should trigger the build. And then hopefully my build goes into production. I'm going to skip a little bit in time now, because it's going to take 4 minutes to run the build, and we don't really have that much time. So that will be the outcome of what we do. So you can see Maven is packaging the project. No problem with Maven Verify, with Maven Package. We're building a container, pushing it to container to the Artifact Registry, but our vulnerability signer doesn't allow this, will not sign this image. So we don't get an attestation on this image, and the build breaks. That's obviously unfortunate, and maybe we should take a look at why that is. So let's go to Artifact Registry and take a look at our container image. Okay, there's the vulnerabilities tab with the scan result. Okay. So critical errors, vulnerabilities with a high impact rating, not just on the operation system level of the container, but also on the Maven dependencies, which is quite interesting. For example, here, probably on the next, no? Yeah, Spring Core, Spring Security, so all's there. Okay, but I really, really want to deploy this container. I don't want to now, what does the attestation even cause? So obviously, the good television cook that I am, I prepared the command already to deploy it. Let's just put our image in here and fire away. I guess Kubernetes will take it anyway. So let's deploy. Oh, that's binary authorization. Since the image doesn't have the proper level of trust, the signing and with that attestation from the vulnerability scanner, binary authorization doesn't allow us to run the image on GKE, which is great. So now I actually have to take care of all of the security vulnerabilities. Let's just pretend that I did and take a look at the next build where I did that. So now wonderful, the vulnerability signer is giving us green light. It's accept the Snow CVEs that it's complaining about, so we actually get the attestation for our image. And as part of the pipeline, we're triggering Cloud Deploy to then deploy the application onto the GKE clusters. In Cloud Build, on Build Artifacts, we can now go to Security Insights, where we get more information about the build artifact. So on the one hand side, we can see, okay, there still are some critical and high-level vulnerabilities that we as an organization made the decision to accept the risk. And we get our SBOM. So here we can really see, okay, what's all the dependencies that went into building this package. So we have the base layers from Docker, but we also have our Java and Maven dependencies in here. And can understand it's actually a long list of what goes into the image. And down here, the new Build Provenance tab, which we remember that's actually a pretty cool feature because we don't just have the SBOM, we also have how was this image built in a way that even after a lot of time, we can still connect these dots. And there we can see, okay, the image was built with Cloud Build on those hosts. That was the entry point for the build. We can see the individual steps that were run, on which containers, what was executed, when was it run, what was the outcome of the individual steps. So really good information for us. Okay, now let's go over into the runtime side, as mentioned earlier. So we now have a secure container that we can actually run on our clusters. So in Kubernetes, we have this new security posture management feature. That's basically the dashboard that you get. And what you can see here is I have 3 clusters. Since my application has to go through our secure build process, it doesn't have a lot of vulnerabilities, so I deployed a few things which will raise concerns. We get 2 things. We have to enable that for our clusters, but we get configuration concerns. So where can we improve our Kubernetes resource definitions? And we get vulnerability concerns for the images that we have deployed. So for example, here we can see that we have a CVE for expat 248R-R0 from the Alpine image. And we have a few configuration images. Now, when you have a lot of workloads running and you maybe have more clusters, that's not helping you to drill it down. So that's where you go to the concerns tab. On concerns, we have different choices how we can analyze these concerns. We can analyze by concern type. For example, okay, this pod container is allowed to run as root concern. We have 5 workloads affected by that. Maybe that's something where we want to do a more of a structured organizational approach to fix it. We can take a look at it on a namespace level, where we can get, okay, this namespace, this workload has these vulnerabilities, or on a per workload level. So for example, the simple Go app has pod container allows privilege escalation. Or, really useful, sometimes you want to start with the most critical things to invest your time wisely. The workday only has so many hours, so you have to decide what you tackle first. So maybe we start actually by the critical problem, the outdated base image. But for us to circle back, let's actually take a look at, from our demo app, at the pod container allows privilege escalation, because I think it's really useful to see we get a recommended action. So here, security posture management really gives us directly a recommendation how we can fix this problem. So we didn't configure any security context in this pod deployment. So it gives us the recommendation, if we don't need it, A, make it explicit, and B, just disable privilege escalation. So here, we just go back into our cloud runtime, cloud workstation, sorry, go into the our deployment. And so yeah, then for this container, I really don't need privilege escalation. Sorry. And just disable it. And that's how we get this continuous scanning in GKE, which informs us, and we're circling back to cloud workstations to then fix the problem. So let's wrap it up. All of the features you have seen today are available in preview. Stuff like binary authorization, actually for a long time, I think it should be at least preview. You can get started if you want to try it out yourself with our quick start tutorials. You should check out our software supply chain security website to get more information on the individual pieces and what you can do and how you can use them. And I recommend that you try listen to the other talks on Google Cloud Next on Cloud Workstations, Gke, NTOS, and CI/CD to get a good picture of all the individual parts that you're using. And that's it. Thank you for your attention and enjoy Cloud Next.
You fix your makeup just so. Guess you don't know you're beautiful.
Hello, developers. Are you ready for our next session? Now we're going to hear about 7 new features that help you simplify building modern applications. So please welcome, representing the Netherlands, and he really does own 5 bikes, Google Cloud Developer Relations Engineer, Wietse Venema.
Hi, my name is Wietse Venema. I'm a developer, and I'm an author. I wrote this book, Building Serverless Applications with Google Cloudrun. It's a short story about the book. It has a bird on the cover. It's an O'Reilly animal book. So O'Reilly doesn't let you pick the animal. They do that for you. So it's a book about cloud computing. So yeah, I got the bird. And when I first showed this book to my daughter, she's 5 years old, she looks at me, "Dad, did you write a book about a bird?" Fair question. So I'm like, "No, it's about containers, running containers in the cloud." So she looks at me, puzzled. Did you put a bird in a container? Well, it's sweet, right? Another thing I like about being a dad is that I can make dad jokes now. Yeah. I like to bring the energy level up. So what do I say to you when there's a duck flying into you? Duck? Okay. And I have another one. So who's from Bavaria? I like to say hands. Okay, I learned a very great dad joke yesterday. I'm going to try this in German. So, welcher Vogel hat nur ein Bein? Ein halbes Brathähnchen? Okay. You can applaud. Yeah, yes. Thank you. Awesome. But I'm here today to tell you about the features we launched in Cloud Functions and Cloudrun. I'll do some live demos. I mean, what can go wrong? Let's get started with Cloud Functions. Cloud Functions are the easiest way to run some code on Google Cloud and extend Google Cloud products. All you need to do is write a function and deploy. You don't need any DevOps experience, and you can connect over 125 Google Cloud and third-party services. So this is when Cloud Functions is useful, if you want to respond to events, if you want to respond and want to transform data as it arrives and store it in a data store, or, and this is my personal favorite, if you want to extend Google Cloud products. So if you have some logic in Java, put it in a Cloud Function and call it from a SQL query in BigQuery. What's new in Cloud Functions? You told us you really liked Cloud Functions, but you wanted more, and that's why we added more. We launched the 2nd generation of Cloud Functions. It has more compute power, longer processing times, and more events. So today, you can select up to 8 CPUs and 32 gigabytes of RAM. This is about enabling workloads that didn't fit on a Cloud Function in the past. And this also helps. We increased the maximum processing time for HTTP-triggered functions to 1 hour, a full hour. And finally, more events. Cloud Functions now supports over 125 event sources through its integration with EventArc. That's 10 times more than before. So Cloud Functions 2nd generation is about more compute power, longer processing times, and more event. But there's more. Do you know that sinking feeling when you've rolled out the change to production and you discover that you made a mistake? Like, I know I do. I pushed a small change that didn't need testing straight to production. Maybe this is not the time and place to tell you about that. But 2nd generation Cloud Functions run on Cloudrun. I know, right? That sounds complicated. But it has been this way all along. So Cloudrun and Cloud Functions run on the same shared infrastructure. But we've now made it even more explicit. That means you can click through and edit the underlying Cloudrun service. And that includes traffic management to the revisions that Cloudrun automatically creates for every deployment. And that's super useful, because sometimes you make an honest mistake and you want to quickly revert, like I did back in 2016. Still know the year. Now here comes my favorite feature. I really like how you can use Cloud Functions to extend other Google Cloud products. BigQuery remote functions lets you call a Cloud function from a SQL query. In case you're not familiar, BigQuery is the serverless data warehouse in Google Cloud. And with remote functions, you can extend BigQuery with code written in Java, Python, JavaScript, or any of the 7 supported languages in Cloud Functions. And that's great for logic that's very easy to express in a general programming language, but very hard to express using SQL. Let's say you're migrating from Hadoop to BigQuery, and you have some logic that's implemented in Java, and you don't want to prioritize moving it over to SQL just now, or maybe never. With remote functions, you put that Java code in a Cloud Function, and you're good to go. Time for a demo. There we go. So I created a Cloud Function. It's barely readable, but I promise that I'm calling the Google Maps API here to get the distance between 2 cities. So let's show how that works. Let's look at my trip back home. So I enter Munich and Amsterdam. It generates this command for me. Oh, I can click the button, testing Cloud Shell. Oh no, reconnect, live demos, you gotta love them. Click the button again, enter. So authorize, of course, yes. My trip back home will take 8 hours and 25 minutes. So now I can call this function from BigQuery. So I have this query. I'll zoom in a bit for you. So from Munich to Amsterdam, Paris, Rome, Stuttgart, and Garching, which is this very famous city nearby. No people from Garching in the room. That's sad. It's 22 minutes away. So there you go. Back to the slides, please. So that was Cloud Functions. Back to the slides, please. Yes, thank you. So that was Cloud Functions. To wrap up, we launched the 2nd generation, and it's more, longer, more. More compute power, longer processing times, and more events. And an improved integration with the rest of Google Cloud. Now, let's talk about Cloudrun. Cloudrun is a fully managed platform that lets you run your code in containers directly on top of Google's infrastructure. There's no Kubernetes in between. Cloudrun runs containers directly on top of Google's infrastructure. And Cloudrun automatically adds more instances to handle all incoming requests or events. It's very simple and automated. There's no infrastructure to manage, no cluster to worry about. It allows you to go faster, to be more productive. Let me put it this way. We've intentionally designed Cloudrun to make developers more productive. And today, Cloudrun is available in all 34 Google Cloud regions. And in every new Google Cloud region, we've announced Austria yesterday, which is nearby, right? Austria, yeah. In every new Google Cloud region we turn on, Cloudrun is available from the get-go. Now, when do you use Cloudrun services? For websites and web applications, use your favorite stack to build your application, using any programming language, access your SQL database, render dynamic HTML pages. You can also use streaming with WebSockets. It's all included. Second is APIs and microservices. So you can build a REST API, a GraphQL API, or private microservices that communicate over HTTP or gRPC. And streaming data processing is a very strong use case. Cloudrun services can receive messages from PubSub and events from EventArc. So this year, we launched Cloudrun Jobs. And you can think of that as cron for the cloud. So a job executes containers to completion. You can start a job using the API, the Google Cloud Console, or you can schedule a recurring job. And just as with services, you only pay for the resources these containers use while they're running, and there's no infrastructure to manage. So to sum up, you can use Cloudrun jobs to run a script that performs database migrations or other operational tasks, to run a scheduled job, think run job, or to perform batch data processing, because Cloudrun jobs also supports parallel processing. So it's time for a demo now. There we go. I will authorize. So this is my shell script. Hey, it's great to have you here. It will just echo a line. In reality, it will do something with Gcloud or connect with my database. My favorite fruit of the day is apple. Oh, that's funny. My favorite food is apple. Apple. OK, good. I will save that. And I'll put it in a container. So I have this Docker file from Ubuntu, add an entry point script, which is the script I just edited, and set that as the entry point. I'll just build that into a container with cloud build, invalid source. Got it. I'm in the wrong directory. And now I execute this command again. OK, so this is what happens with live demos. I like it. New shell. This should be Gcloud to change to different. Yes, this will work. There we go. OK, so this should take 18 seconds. We'll have to be patient. If you know a fun joke, tell me. I can share it with the rest. No takers. So it uploaded the source. It's building the Docker image using Cloud Build. It's pushing the image. So now, when it's done, I can go over to Jobs. I click Create New Job. Select the container image. The latest one. You can see I tested this many times. It can't go wrong. I give it a name, and I execute the job immediately. So this is one of those 3 ways to start a job: API, Google Cloud Console, or you can also schedule it using Cloud Scheduler. And it's already executing. So when it finishes, I will switch to the Logs tab, and I will see my favorite fruit. Very exciting demo, watching the spinner. Hey, it's great to have you here. My favorite fruit is apple. Thank you. I think it's really great when you clap when I actually finish my demo. Back to the slides, please. So in the title of this talk, I promised you 7 new features in Cloudrun. And before I dive in, here's what I'll cover: Datadog integration, health checks, CPU boost, software delivery shield. You've been hearing a lot about that today. Security recommendations, and cloud deploy and integrations. So I cheated a bit because the last one, integrations, is actually 2 features. First, we're proud to announce a partnership with Datadog around observability. So you can use the official Datadog in-container agent to send logs, traces, and metrics to Datadog. Feature number 2, we are introducing health checks on Cloudrun. And to understand what those are, let's look at the life cycle of a container. So there's the startup phase, when your containers are getting ready to serve requests. And there's the serving phase, when it actually serves requests. So when does a container transition from starting to serving? Anyone knows? It uses a TCP startup probe. So as soon as your container listens on a TCP port, bam, it starts to serve requests. With Cloudrun health checks, you can customize the probe. So in addition to TCP, you can now configure an HTTP probe. And this is useful for apps that start listening on a TCP port before they are actually ready to serve requests. Looking at you, big Spring Boot app. We're also introducing a new kind of probe, liveness probes. A liveness probe determines if a container is still able to serve requests. If it's not, it will be shut down, and Cloudrun starts a new container. So you can use liveness probes to stop container instances that get into a corrupt local state, or force a restart after a certain amount of time. Feature number 3 is Startup CPU Boost, and it helps improve scaling speed. So, as you know, Cloudrun automatically adds container instances to handle all incoming requests. That's called auto-scaling. And container startup time is very important when it comes to scaling. So the faster a container instance becomes available, the faster it can handle requests. And the faster Cloudrun can scale your service. So to improve your container startup time, you can do one of 2 things. The first thing is, well, change your code. Decrease your container startup time. Maybe you start lazy loading dependencies. Maybe you try to remove things that it is auto-loading so it starts up faster. And the second thing you can do is, well, configure more CPU, because usually that improves the startup time, especially when you're using 1 or 2 CPUs. That sounds great, right? You pay more, and it starts faster, and you don't have to make any code changes. Yeah, but it's also more expensive. So that's why we've came up with Startup Boost. With CPU Boost, we dynamically double the number of CPUs we allocate to a container instance during startup only. So as soon as the container finishes startup, we reduce the number of CPUs again, so you won't be charged for using double the amount during the entire container lifecycle. And we've observed that this can almost cut in half the startup of some workloads. For example, when you use Spring Boot with 1 or 2 CPUs, and I know I can see some faces in the audience, you won't believe me, so I will show you. I'm a recovering Java developer, so let's go to my demo. I initialized a Spring Boot app, and I deployed it to Cloudrun. It's a fairly simple app. All I did was initialize it and added an endpoint that lets you admire my web design skills. It says, hello, Munich. And I deployed it to Cloudrun, and it now says that it starts in about running, JVM running for 8.5 seconds, 8.1. I also added an endpoint that let me stop the container because, well, makes it better to collect demo information. About 8 seconds. So I can go into edit and deploy a new revision, and turn on startup CPU boost and deploy it again. So that will take some time, and I will need to collect the logs again. So I've deployed the same exact container image in this other service that I've called Spring Boost. It was funny. I thought it was funny. Anyway, but this one starts in almost half the time. So it's 4 seconds, 4.5 seconds, 4.8. So this one will scale faster, and I won't pay much more. So that's good. Let's go back to the slides. Let's go back to the slides. For feature number 4. Can we go back to the slides, please? Software delivery suite. The security of the software supply chain is top of mind today. And that's why we've enriched the built-in security panel with software delivery shield. It shows security information. For example, the Salsa level of your container. So Salsa is an acronym. It stands for Supply Chain Levels for Software Artifacts. It defines a level of assurance for your workload. So if you automatically build from your Git repository using Cloud Build, you will be already on level 2, as Cloud Build captures source provenance and it signs artifacts by default. And additionally, it displays vulnerabilities that were found in your deployed container image, grouped by severity. But we're doing more to help you secure your Cloudrun service. We've added 2 new security recommendations with Active Assist. Active Assist scans the configuration of your Cloudrun service, and it looks for, well, recommendations to make. And it will now suggest to use Secret Manager if it detects that your environment variables might contain API keys or passwords. So if you have an environment variable that says API key or it says password, well, so maybe you want to use Secret Manager. Click here to enable. I think that's pretty cool. It also recommends to use the built-in service identity if it detects that you might be storing those passkey long-term service account credentials as a file inside of your container image. I hope you're not doing that. But if you do, Cloudrun will tell you. Feature number 6, Cloud Deploy is a fully managed continuous delivery solution, and it lets you manage the release of your container in a pipeline. So with Cloud Build, it was a bit of a manual work to get that all working. So with Cloud Build, Cloud Deploy, you can manage that from developer environments to staging to production. And it now has direct support for Cloudrun. And finally, integrations. I've said this before, Cloudrun has been intentionally designed to make developers more productive. And we're constantly looking for ways to improve that. So one of those opportunities is to reduce the amount of manual steps you have to do with automation. So here are 2 examples of common tasks that require a lot of steps to do with Cloudrun today. Creating a Cloud Memory Store instance and connecting it to the Cloudrun service, because you have to add this serverless VPC connector, wire through the IP to the Cloudrun service, et cetera, et cetera. The second thing is setting up the global external HTTPS load balancer in front of your Cloudrun service with a custom domain, right? Because that lets you take advantage of Cloud CDN and Cloud Armor, enable easier migrations. Both tasks are not hard or complex, but they do require a lot of manual work. You have to read the docs, follow a long list of steps, make sure not to click on the wrong button. So Cloudrun integrations is like that robot that does all the work for you. You tell it to create a memory instance and bind it to your service, and it does that for you. So look, if you forgot anything else from what I told you today, I hope you're remembering the amazing dad jokes. Remember this one thing. We've intentionally designed Cloudrun to make developers more productive, and we're looking to improve that every single day. Thank you. Thank you.
And if your mirror won't make it any clearer, I'll be the one to let you know.
Hi, developers. We're entering in the home stretch of our tech talks. And up next, I know I'm super excited to hear about serverless and sustainability in one. So we'll hear about how switching to serverless saves on cost and can save the planet. Please welcome to the stage respected leaders of the customer-to-customer, or C2C, community in France, Guillaume Blaquier, data architect for Carrefour, and Antoine Castex, data architect at L'Oréal.
Thank you for joining. The target of the presentation of today is to explain you how is it very interesting for you in terms of architecture choice that you will make to save first your money and also the planet. So my name is Antoine. I am working for L'Oréal.
I'm Guillaume Blaquier. I'm working for Carrefour.
I will not do any introduction about L'Oréal because I'm pretty sure already everybody knows very well L'Oréal. So first #1 cosmetic luxury group in the world, present in more than 50 countries with 19,000 employees.
And Carrefour is one of the major retailers in France and in Europe, and our company are concerned about sustainability and to save the planet. Carrefour, for example, take care of the plastic in the store and take care also in the cloud to how you consume our services. Antoine and I are friends. We are leading the C2C France community. We are a group data architects in a large group, and we have a data lake, data warehouse, and we have similar problem. Can you tell us more about this problem?
So the problem seems to be very simple to solve, but we will see that there is different way to solve that problem. Imagine you are like me and Guillaume, you have some data, you have choose a dedicated cloud provider, which I hope it's Google Cloud. Huh? You put data, and more data. At the end, the target is to have more and more data, but you really want to know what the data you have in terms of how many lines of row, where the data is located, because it can be sometimes in some place and sometimes in another place because of some reason, huh? Security or legal restriction. But you need some data about this data. I call that metrics. Usually it's more metadata, but I would say it's data about data, okay? So the story we have to tell you today is we are trying to have metadata every day about the data usage that we have. Too much complicated. Huh? In terms of what? We will tell you to have this metadata, how much carbon footprint it's consumed to have this information every day, how much cost, and how long it takes to have this metadata, okay?
Yeah, and for that we will have several solutions. Why I mean solution? Because when you use a cloud provider, Google Cloud or others, you have many times a different way to do the same thing. You can use raw services like VMs and build what you want on top of VMs, or manage your serverless services with less customization, but more flexible and more managed way to do the things. I will present you 3 different ways, and the first one is the old good way, is the VM. What we do in our VM is to, in sequence, request all the projects on our organization. For all the projects, we request all the datasets. For all the datasets, we request all the tables and get the metadata on the tables, number of rows, volumes, and so on. And we do that in sequence. And it takes a time, but it finishes, I think.
So imagine you do table by table, dataset by dataset. A company like mine and the one from Guillaume has a lot of tables, and I'm sure you already know, because it's big. It takes 24 hours. So, okay, not that bad, but imagine if tomorrow we have more data. Remember what I say as an introduction, I need this data at least 1 time per day. So if it takes 26 hours, I have a problem. So that's my first problem. The second problem, I don't know if it's the case or not, it's the cost. I don't know how much money do you have, but okay, I see it costs more than $4,000 per month. Per month meaning 1 run per day. So it's 1 run per day. Additionally, at the end of the month, that's the price. Huh? It's not the price of 1 run, of course. And in terms of CO2, we have a number. Okay. approximately 200 kilograms of CO2. We don't know if it's good or bad, but do we have another solution?
Yeah, we use another solution and a more modern solution. We use a solution based on containers. And we use managed services. We use App Engine Flex to deploy custom containers on App Engine Flex. What's App Engine Flex? It's a managed solution or PaaS, platform as a service, and in my definition is a service that you have nothing to configure. You take your container, you deploy your container, and magically it's run. It's auto-scale according to the traffic on your container. It scale up and down, and it keep always one instance warm at least to be sure to be ready to process the new request incoming. With App Engine, we designed this architecture with a Cloud scheduler that trigger endpoint on App Engine that create a lot of tasks in Cloud Task, and then in parallel you have other endpoints to on the same App Engine services to request the metadata on BigQuery. The task, for example, is request this project, this dataset, and this table, and you do that in parallel. And the result is quite different.
So the result, in terms of time, we see not so big difference. So not very great. In terms of money, first great news. Okay, I can save a lot of money for myself to doing something else. In terms of CO2, again, it's very, very different because you compare two different kinds of architecture and different generation of solution. But can we do something better, Guillaume?
Yeah, we can do something better because App Engine Flex is quite old. It has been released, I think, 10 years ago, quite old, and we have modern services. It's named Cloudrun. Cloudrun is a serverless product, so the difference, again, for me, in my definition, that's, again, like managed services, you have nothing to configure. Easily, you can take your container and deploy it. It scales automatically from 0 to hundreds, thousands of instances. And especially because you can scale to 0, you pay only for what you use. If you don't use it, you don't have instances and you don't pay for it. If you start to use it, of course, you start to pay. And one of the most popular services for running containers on Google Cloud is Cloudrun. Cloudrun is container-based, so container also is very popular because it's a modern way to package any application, any binaries. It scales automatically, of course, as I said. He also manages concurrent requests. If you have a look to Cloud Function, for example, with Cloud Function, you can, Cloud Function first generation, you can process only one request on one instance. So if you have 10 requests, you have 10 instances, and it's not very efficient. With Cloudrun, you can have a concurrent processing on the same instance. You have 10 requests processed in the same time. And the most interesting feature for me is the Knative compliance. In fact, Cloudrun implements Knative APIs. That means if you install Knative on top of any other Kubernetes cluster, on GKE, on-prem, on other cloud provider, you can deploy the exact same container on Cloudrun and on Knative. That's wonderful for the portability. I would like to perform a focus about the concurrency and the billing. Why? Because in fact, here you can see that you start to pay, it's the blue part, when the first request comes in and when the latest request has been processed. That's the blue part. You can process several requests in the same time. And the gray part, in fact, the instance is up and running, but no requests are processed and you don't pay for that. Maybe Google pay, but not you. And that's why it's very important and very efficient in terms of cost and processing. A last word about the architecture, the exact same as App Engine Flex. Why? Because you use the exact same container, but deploy on other platform. Again, a cloud scheduler, a first endpoint to create a lot of tasks, and then to have a parallel processing of the task on Cloudrun again. And the result is difference.
So the number, you can see we'd increase a lot the time elapsed to do the job. So that's a good news because remember what I say, normally we will have more and more data on this data warehouse today, next month, next year. So it's good to see that scalability for the future will be okay. We also decrease the money we spend, so another great news for you, but also for me. Huh? And also in terms of CO2, okay, 25% less, it is very great. So let me give you an overview of the two results, but before that, I just want to say, where are these results coming from, very quickly. First is the CO2. CO2 is coming from the carbon footprint dashboard of the Cloud Console that you all already have access to. We do an export on BigQuery every day and we use the data. Billing also comes from the billing export that is natively available and exposed into BigQuery on a table on a daily basis. And the time elapsed is measured basically on cloud monitoring, looking at the logs, beginning, end of the job. And we do the report for you to be there with you today. So we have the three evaluations. You can see difference. But Guillaume, I am a little bit interesting to know why between some recent architecture, we have this difference. Can you explain me the difference between the PaaS and the serverless?
Yes, because it's strange because you use the same container, the same architecture, and we don't have the same result in terms of performance, in terms of CO2, in terms of cost. In fact, as I said, when you use solutions on the cloud, you have different ways, and according to the service and the solutions that you implement, you have different behavior at the end. In fact, with App Engine Flex, you have two things. The first one, App Engine Flex never scales to 0. That means you have at least one instance up and running. That's why the green line never scales to 0. Then, when you have a parallel processing of many tasks, the problem is the following. With App Engine Flex, the scalability is not based on the number of requests, it's based on the CPU usage. And when you query an API like BigQuery to get the metadata, what you do? You wait. You perform an API call and you wait for an answer. And of course, if you wait, you don't use CPU time and you don't scale so much. The difference with Cloudrun, so you scale to 0, but the autoscaler is based on the number of requests that you have. And because you have a lot of requests in parallel, you can scale very fast from 0 instance to more than 700 instances during 2 hours per day. And that's the difference of cost and speed. But that's not the only one difference between serverless and older architecture or legacy or standard architecture. And I'm sure, Antoine, you have one bonus for us.
A little bonus, which is not a technical one, but very important for you also. The choice that you will make, and it's basically the conclusion of this presentation, is very important in terms of what we call the shared responsibility model. Because if you prefer to do some infrastructure more than some serverless, it is not a problem. Huh? We are not saying this is bad. We are just saying keep in mind that you have something to do that is different than if you select serverless in terms of contract of responsibility between you and the cloud provider. Okay, if I have the VM, if I prefer having the possibility to customize something, but I also have the mission to update the VM, where if I use Cloudrun, it is not my job to do that. I let that to Google. So it's very important to keep that in mind. But do we have a last bonus, Guillaume?
Yes. Also a bonus in terms of high availability. Why? Because if you have to have a metrics every day, you have to be sure that your process runs every day. And if not, you have an issue in your following of the metrics. That's why you want to be high available, at least at regional scale, where you run your app. And if you have a VM, in our example, in fact, you need to have an architecture that makes you resilient in case of issues of your VM. So if you deploy something in one region, we deploy one VM. But if the VM goes down, you need to have other VM up and running to continue your processing. But you don't need 2 VM. In fact, you need 3 VM. Why? You have to prevent to face this pattern. You have one instance goes down, the other one is in maintenance, and the third one is ready to serve your traffic. That's why you need at least 3 VM in one zone to be high available in one zone. Now, if you want to be high available at regional scale, you need to repeat this pattern for all the zones of your region. So at least 3 VM for 3 zones, 9 VM at the end. When you have a look to serverless, it's not the same. If you have the ability to deploy services on serverless, in fact, you never mention the zone. Only the region, in fact. You deploy Cloudrun, App Engine, or Cloud Function on a region. Why? Because natively, it's not deployed on one zone, but in all the zones of the region. So by default, and out of the box, serverless products are natively high available at regional scale. And remember, you pay for what you use. Remember also the difference in terms of cost and carbon footprint for serverless with Cloudrun and with 1 VM. Here, 9 VM. For me, the serverless is really the future to save money, to save the planet, and also to save time, to go faster, to deliver values. So thank you very much. Thank you for your time. If you want to have some question, Twitter, LinkedIn, or so on, don't hesitate to reach us, Antoine and I. And thank you very much for your attention, and enjoy your rest of your day.
Thank you.
Thank you.
Hey, developers. We are down to our last tech talk that will be live broadcast also to our audience on the internet from Europe, Middle East, and Africa. And for this last session, let's learn how to easily move from raw data to machine learning. And we'll hear about this from our Google Cloud Machine Learning Product Specialist, Kamu Ma. Welcome.
Hello, everyone, and welcome to the final session on how to move from raw data to ML faster with BigQuery and Vertex AI. First off, let me introduce myself. My name is Kamu Ma. I manage the customer engineering team for the South EMEA region, specialized on machine learning and AI. So let's begin the session. How do you move from data to machine learning? So what are the barriers between data and machine learning that we often see with our partners and customers, and even internally at Google, which continue to slow innovation? First, let's start with data. Data is often big and multi-formatted, which means there are many data silos, copies of data, and makes data hard to discover and extract value from. Then, AI and ML systems are often isolated from data, leading to more needs of integration, security risks, and unsuccessful machine learning deployments. So first, how do you get from data to machine learning? Let's look at the data piece. You need the data engineering steps. This includes data ingestion, data preparation, data storage, and often some sort of data cataloging. And then you move to data analysis, where you need data exploration, data preprocessing to gain data insights. So how do you extract even more value with machine learning? First, you have the model development step, where you do feature engineering, model training, register your models in a model registry, and some type of model evaluation. And then you do ML engineering with model serving, model deployment, and model monitoring, with feature store in between. And finally, you have insights activation, where you could use your learnings from your machine learning and data analysis to influence business decision, customer decisions, and serve downstream applications. We've also added the horizontal component of orchestration, so you could automate your ML pipelines and data pipelines with CI/CD. So these slides show how you could build an entire data to ML journey with Data Cloud, Google Data Cloud. And I would like to say that this is not all of our services provided on our platform. This is just an example of some of the tools that you can use to get value from your data on GCP. So on my right here, you have any type of data that can be ingested inside GCP and more. So your data could come from corporate and third-party systems, e-commerce, SaaS applications, IoT devices, social media, or geospatial data, and more. And then it could get ingested on GCP with data engineering using Dataproc and Dataflow. And I'd like to point out here that Dataproc is a serverless version of Spark, and Dataflow is a serverless version of open source Beam. And this is indicative of all our services where we try to have a managed version of open source software to have the most open platform available. Next, we have data analysis using BigQuery or the data analysis tool of your choice. You could do model development on Vertex AI and BigQuery ML, ML engineering on Vertex AI, and insights activation on Vertex AI, Looker, App Engine, or other downstream services. This can help with any innovation. Here are some that we listed, but I'm sure you have some in mind or some already in production. So decision making, app development, SaaS applications, exception management, and so on. You also have the horizontal orchestration layer to automate each of these steps to scale and put these models into production. We propose here Cloud Composer or Vertex AI pipelines. Cloud Composer is a managed version of open source software as well, and Vertex AI pipelines supports 2 open source SDK, TensorFlow Extended, as well as Kubeflow Pipelines SDK. And we really designed and built this platform to meet the needs and expertise of various users that you see listed above, and more. So data engineers, machine learning engineers, data scientists, data analysis, business users, to add value to the customer. So how do you get to this full ML production system? We have designed a journey from crawl, walk, and run. This is very high level, but we hope it'll resonate with you. So first, we propose to start with Vertex AI Workbench. Vertex AI Workbench is a Jupyter-based, fully managed, scalable, enterprise-ready data science experience with easily enforceable policies and user management. So we see with our users that they could get to production ML models faster with Vertex AI Workbench compared to traditional Jupyter notebooks. And this is the case because we've added extensions to simplify data access. So you can seamlessly and out of the box connect to your data source in BigQuery, Google Cloud Storage, and other data sources. We also support in-place data exploration with SQL and Spark queries from a syntax-aware, autocomplete-enabled notebook cell. And also, we support multiple environments out of the box. So whether you're using TensorFlow, PyTorch, or Spark, you could run any of these engines from the same Vertex AI Workbench instance. This means you don't need to have multiple servers for different environments, and this saves you time from maintaining and keeping running multiple servers as well, and costs. So now that you can crawl with the Workbench, how can you walk and start to train and deploy your models? So this is an illustration of how you could do this on Vertex AI. So your data could come from BigLake. If it's tabular, it could come from BigQuery, or it could come from Google Cloud Storage. Then you do your data engineering step. You could use one or all of BigQuery, Dataproc, and Dataflow. And then you move on to model training on AutoML, Vertex AI custom models, or BigQuery ML. And then you can register your models in Vertex Model Registry and deploy these models for batch inference on BigQuery ML or Vertex AI endpoints for batch and live inference to power your downstream applications. I'm also now very excited to announce that Model Registry on Vertex AI is now generally available. So Vertex AI Model Registry allows you to have models registered from AutoML, BigQuery ML, or Vertex AI custom models. So all your models could be in one place for easy reuse, tracking, and model versioning. We also allow you to add labels and aliases to your models to facilitate model discovery. Another feature is that you can seamlessly deploy your models to Vertex AI endpoints using the UI or via a Vertex AI SDK. And finally, all this is integrated into our Vertex AI SDK, so you really have a unified Vertex AI experience. So how do you really run with machine learning? We've added here to the previous diagram the Vertex AI pipelines, Cloud Build, and CI/CD block up top. So what this means is that now you can automate each of the steps in your machine learning pipeline. You could substitute Vertex AI with Cloud Composer, as mentioned previously, or with another orchestration tool. Same with Cloud Build and CI/CD. You could use Cloud Repositories or its equivalent. We also added Feature Store. So this will enable you to share features, reuse them, and also version your features. Here is how a Vertex AI pipeline could look like. So each of these blocks you see in this diagram is a Vertex AI component, and it's a step in your ML pipeline. And this could all be orchestrated with additional features, such as runtime parameters and conditionals. We're also very happy to announce that now we have 20+ pre-built BigQuery ML operators available for you. What this means is that previously you would have to create your own custom component if you were to use BigQuery ML in the Vertex pipelines. But now we have 20+ pre-built components which are maintained and supported by Google engineers. So this enables you to deploy your BigQuery ML pipelines inside production in Vertex AI much faster. And lastly, I want to leave you with a very exciting private preview feature we have on BigQuery ML. Before, you could only use BigQuery ML on structured data. But now you can actually tap into the value of BigQuery ML with your unstructured data as well. This means that if you have a lot of images or text files stored in Google Cloud Storage, you could leverage BigLake and BigQuery ML to extract value using machine learning. How can you do this? So I'd like to illustrate how you can do this with an example of a hypothetical customer. This is a real estate customer who wants to predict the click-through rate of homes on their website. So the current models uses a lot of structured data, like the home location, the size of the house, for instance, to train the model. However, they may have thousands of images stored on Google Cloud Storage that's not taken into consideration inside the model today, but this could drive a lot of business insight. So if they want to use images, they would have to process the images separately. So how do we make this experience better for them? So right now in private preview, you can create an object table in BigQuery where all the images in Google Cloud Storage are indexed. And you do this simply by just creating an object table with this simple SQL query, pointing to each of the location of your image. Next, you import your model inside BigQuery. So right now, you have your computer vision model imported with a create model and pointing to the location of where your model is stored. And then afterwards, you run a simple ML predict using the model and the object table to create latent representations in a table, which you could then join to your structured data to power your machine learning model training. So in 3 easy steps, you can actually have unstructured latent representations embedded into your new model. And this is the last slide of my presentation. I'll leave you to enjoy the rest of Google Cloud Next. Thank you very much.
One by one, I know we've seen some things that could have torn us apart.
Hey, so actually we've come to the end of the technical content that will be live streamed today, but we're super excited that we have a lot more going on here on site. So I just want to say I hope you've been able to make the most of it, and thank you all online for your participation, and hope you have a chance to sign up as an innovator for Google Cloud so you have access to all of our live events. You find out where we're hosting challenges near you in the future. And sign up for the Drone Racing League Challenge as well. And those of you here, hope you had a chance to interact with our architects, play a couple games, ask some questions, get involved in the Google Cloud community. So I'd really like to personally thank you on behalf of all of the Googlers here and the local teams. We're looking to really bring more GCP developer activities to all of you locally and virtually. So what's happening now? Well, you are the heart of everything that we do. So that's why we decided to make some hands-on workshops for those of you here, locally guided by our experts, and we'll have one here in this main room, and we'll have one upstairs. And unfortunately for those online, we have to say goodbye. But again, thank you, and the future is for developers, and we'll see each other again soon. We'll also have a reception for the local folks here. So after your hands-on workshop, which remember to get your swag stamps for, we'll then come back and there'll be some changes, and we'll have a chance to have some food and some drinks and connect even in a more casual way. So the other workshops are from Po Long Ling and other champion innovators. So that is the building an end-to-end data and ML solution on GCP workshop. And the second one is upstairs in our Atlanta room, and that's Spark for data engineers and data scientists, and that'll be with Brad Moreau. So you can take a quick break here and then join the last workshop. And then we'll see each other for our well-deserved celebration at the end, back here in the master ballroom. All right, thank you all. Ciao.